Hello, everyone, and welcome to the Intense Crash Course in Objective-C with your lead instructors, Nelson, Jason. Yeah, and also joining us, we've got the lovely Nina.
Hello.
Who's got a little bitty MacBook Air with her tonight with Xcode on it, so she no longer has to do any coding on paper.
Yay!
So let's start out by saying welcome to those of you that returned for another exciting, fun-filled evening with us. We've lost about 10 people. Aw, I guess they couldn't take it.
Couldn't handle the pressure.
I like that you guys are just, dedicated and hanging in there. It's absolutely awesome. So we do have a lot of things that we're going to be doing tonight. So first thing I want to do is just give you a quick overview of what is planned. First, we're going to start out with Nelson doing just a quick review of the things we talked about last week. It will be accelerated, 10 minutes or less, and then we will be moving from there into week 2. And for week 2, we're going to start out by having a little bit of fun by taking a look at a few new operators, because I'm going to need those throughout the different things we're going to be doing tonight. From there, we're going to talk about flow control so that we can, create intelligent applications. From there, we're going to be moving into the world of functions. We're going to talk about defining functions, invoking them, parameter scope, return types, all sorts of stuff. We're also going to talk about stack frames as well. Stacks and stack frames. And then finally, we'll do some recursion, and that will pretty much wrap it up. So as you guys can see, it's a very simple night in front of us. I'm quite excited and ready to get going. So with that, I'm going to hand it over to Nelson to give us a quick review. What did we talk about last time, Nelson?
We talked about Objective-C.
No, we didn't.
We didn't?
Well, maybe for about...
I did last week.
We did for about 3 minutes.
Oh, right. Okay, well, yeah. We mainly talked about C, as Objective-C is built as an extension to the C programming language. And we went over quite a bit. We started talking about the IDE itself, which you see right here. The IDE being the integrated development environment where you write and compile code. We talked about a simple application, so something that looked like printf, hello world. So something like this, we talked about that. We talked about the project anatomy, which basically at this point, the only thing we need to really concern ourselves with is this main.c file right here. Then we talked for the rest of the class about the anatomy of what all these symbols mean, all these symbols and words mean, as well as we talked a little bit about data. So in the case of what this particular program means, what we have here on line 1 is an include directive, which brings in the stdbool.h header file, which stands for standard input and output. This is the standard library that you use in C in order to read and write to the console window. Then we went ahead and talked a little bit about functions, how right here what we have is a function definition for a function called main that returns an int. And this function has 2 statements inside of it. The first statement is a printf invocation, meaning we're instructing the computer to invoke the printf function with whatever arguments that we pass into it. In this case, the string literal hello world. The final expression or statement, on this particular function is the return statement, return 0, which instructs the compiler to pass the value, the integer value 0 back to whoever invoked main, which in the case of this program is the operating system. Now, keep in mind that main is the entry point to our program, meaning that program execution will start with the first statement inside of the function called main. So we have a function, we called it main, and we have a statement inside of it. So that means line 5 is going to be the first executable line of code in our program. This include stdio is not executable code. It doesn't, although it does instruct the compiler to perform some operations, it doesn't actually impact the runtime of our program unless we were to invoke functions that were received from this particular header. So after we talked about the basic anatomy of the Hello World program, we talked about variables. So for example, I can declare a variable called X bar equals 10. In this case, what I have here is a variable, and we know it's a variable because it follows this form. This form being a type, then an identifier. The type in this case is int, which is short for integer. The integer type can, you can store any whole number, negative or positive, inside of this data type. The next token, what we have here, is called an identifier. An identifier is nothing more than a human-friendly name to something. So in this case, we have created the identifier, xbar, and associated it with this variable. Now, whenever we call upon xbar inside of this main function, the compiler knows what we were talking about. Then we have an initialization expression where we initialize xbar to the value of 10. Keep in mind that this is optional. We could very well do this. However, if we were to print this particular expression out to the screen, what we're going to get is
yeah, so he's like breaking one of the rules that I tried to stress last time.
Yep. So what we get right here is garbage.
That's right. So go home.
Initialized it. So it's
he is home.
Yeah. Like over here.
So you need to always initialize these variables as you create them.
Yep. And keep in mind that unlike mathematics or certain other languages, variables may change their value during the execution of a program. They're mutable, which means I could go ahead and reassign xbar to whatever I want. Or in this case, assign 10 to xbar.
But Nelson, say later on I made the mistake while still inside the main function there and tried doing int xbar again.
Inside of most programming languages, once you declare a identifier, in this case we've declared an identifier up here called xbar, you cannot redeclare another identifier with the same name. So if, for example, if I were to do int xbar again, I'll get a compiler error because I'm attempting to reassign the meaning of this name. And as you see right here, we have a redefinition of xbar. So, so we talked about that. We also talked about user input. So, for example, if I wanted to ask the user for something, I could do something like this. First, what you see me setting up here is the prompt, followed by a scanf invocation. The scanf invocation tells the CPU that we want to pause the console and wait for the user to type in some input. And that input will be placed into whatever variable that we pass the address of into this function. And this particular bit, particularly this, this little ampersand right here, will make a whole lot more sense once we start talking about pointers. But now that xbar has been assigned to user input, I can go ahead and use it however I wanted to. So I could go ahead and say, you entered blah. So now if I were to go ahead and run this program, notice how the console is now paused, waiting for me to type in a number. And if I typed in 45, it says you entered 45, and the program terminates. So we talked about console input and console output. The last thing that we talked about in the class last week were the different types of variables that we can declare. And C has a few built-in types that we can use. So, for example, we can have int, we can have float, we can have double, we can have char. And remember, the difference between the different types are going to be essentially what kind of data that the particular type is suited to store and how much memory that particular type takes to store physically in memory, in RAM, I mean. So in this case, we have an int, which is 4 bytes wide on this operating system. And it can store integral data. It can store negative and positive whole numbers. Then we have a float. That's a floating point number. In this particular case, on this operating system, a float is 4 bytes, and it can contain any number that has a decimal point in it. But keep in mind that the precision of this number is limited to how many bytes that it consumes in memory. obviously, because all primitive data types are fixed width, meaning they always consume the same amount of memory in RAM, there's a fixed amount of precision that any particular variable can hold. So a float has a relatively low precision when compared to a double. And a double is, like the name implies, a double float, basically. So it's the same type of data. It's still floating point data, but there's twice as many bits that can hold the data. So as a result, it's more precise. Then we have a char. Char on this operating system is a single byte wide, and it does contain integral data. However, the semantics of this type indicate that it should be ASCII encoded. And that means that as you're working with your program, you should use chars to contain characters, such as the character A, for example. Or if occasionally you'll have times where you really want to store an integral value in a single byte, in which case you can certainly abuse the char type to support that use case. So yeah, that's really about it.
Yeah, I think so. Now, there was a question about homework and knowing, if it was acceptable or not. Just want to remind everyone that right now with the new website not yet available, you guys are submitting them through email. There's still a few that we have to go over. It's not a streamlined system like it will be very, very soon. So if we run into anybody that they had problems with it, then we will be getting back with you to let you resubmit it. So you'll have nothing to worry about. And if you don't hear anything back, then you're good to go. Because we've got a lot of people that are taking advantage of people, like us looking at homework and grading, so they're submitting stuff. And we've got a lot of people that are not participating in the live class that still watch the video after it has been uploaded to 3D Buzz and then do homework and turn it in. Now, once the new system's live, you'll see when we've actually looked at it, because we have to go in there and sign off on it. So you'll see passed or failed and need to resubmit and all that. Again, it'll be streamlined. So right now it's a lot more involved, and we have to go and hunt that person down, get their email address from Nina, or if she includes it, then write them back. And so we just limit it down to people that have trouble with their homework. But again, that's hopefully, I'm looking over here at MMO Dust. Said hopefully the new site goes live for all sometime soon. Totally agree. At the very least, I'd like to make it available to you guys. Nelson, tomorrow we should look at it and see how close we are to being able to just let these guys in. The aesthetics and all aren't complete, but the functionality's there so that you guys can start using the class system, and we can also use it as well for grading your stuff. And that would make it, again, a lot more streamlined for everybody, you guys and us. Plus, also, as videos are now being put up, those that are using the beta site can now watch the videos on their iPads, their iPhones, their Android tablets, and Android phones, which is quite nice also. So it's good to have those things available. So anyways, with that, thank you very much, Nelson. Let's go ahead and jump over to one of my screens. Let me figure out which one of these I want to use. Let's do this here. Make presenter, and wrong mouse again. Wait a minute. No, not that one. I wanted to make him presenter. And why does it bring it up here? Oh, well, okay then. Nina can tell you how confusing this is. It is jumping.
27 screens and
it is jumping all over the place. It's the first time using, last week was the first time using it, but it's just kind of confusing when we've got so many different screens and computers that are having to be used per desk. So tonight, let's kick things off by talking about some increment and decrement operators that are going to be useful to us as we work our way forward. Again, for those of you that have been programming for some time, remember this is a class that is geared towards beginners only. So at this point in time, go get some pudding and shut up. Go to sleep, watch something on TV, and listen to us in the background. So something that we do often as programmers is go in, take some sort of value, and add to it. We count. We count a lot. We find ourselves counting as we're iterating through loops and other processes that we do. So there are some operators that will simplify the amount of code that we have to write. So what we're going to take a look at first is we're going to start out with the increment and the decrement operators. So increment, decrement. So if I come over here and wrote a little program that said int x equals 0, and then on the next line I want it to say x equals x plus 1. We saw that last week by declaring a variable. We have a place in memory that will now hold data of the type specified, in this case an integer, and we have an identifier that allows us to gain access back to it. We see that we have initialized it to a 0, and on the next line of execution, we now take whatever is currently in it and we add 1 to it. So we go from a 0 up to a 1, and my eraser has decided to break. Awesome. So anyways, we now go up to a 1. There's a shorter way of writing this. So this line right here, if we say x plus plus terminator, same exact thing. This is just saying take whatever is currently in this variable and increment it by 1. Is that easy, right? So if I said x equals 36, the most challenging question of the entire night, if I, on the next line, said x plus plus, after the execution of this line, what is currently in x?
37.
37. Nina beat everybody, but MMO Dust was close. Okay, that's right. Because we've simply taken and incremented the value that was in there by 1. That is an increment operator. Now, the decrement operator, I know this is going to blow your mind. But if I came over here and again had int x equals, and let's start it out, initialized to a value of 10, and on the next line said x minus minus terminator, lo and behold, what do you think this is going to do?
9.
9. This is the exact same thing. It's saying x equals x minus 1. And again, you're going to see the use of the increment and the decrement operators quite a bit as we work our way forward, especially when we start getting into loops. But now, here's where things get cool. When working with these two operators, there's two different versions of the increment and decrement operators, if you will. You have a prefix version, and you have a postfix version. What the prefix version is going to do, well, actually, what you've looked at so far has been, any guesses? Post. Okay, so this is going to allow us to increment after this line is done. If there was anything else that needs to be done on this line. So let me see, a good way for that to make sense would be if I said int, let's go ahead and say int y equals 5. And I had x equals 10, and we'll just stipulate that when I forget that terminators are there. Then if I said y equals y plus x plus plus terminator. Oh, dear heavens, it looks like I'm suddenly doing complicated algebra stuff. How did we manage to get back into algebra? No, this is real simple stuff. So here, doing a postfix, what we're saying is that we're going to increment x by 1 after we've evaluated the expression and all. So what is the output of this?
16.
Output's going to be 16? Any thoughts over there on the side?
I know.
16. Oh, you're so good, Nelson. So help me remember what I was just doing. So let's go and let's just so that I can get used to touching my keyboard over here. So we had what? Int y equals like 10, and then I had an int x equals, and what did I set it to?
5.
5. And then we can say that y equals y plus x plus plus terminator. And then on the next line we can say printf, and we can say y equals, and then make sure to do our new line, and then let's come over here and say whatever is currently in y. So go ahead and run this. So I've got a 15 there. Why do I got a 15? But what if I also came in here and said, but x equals %d and a new line. And remember, I can come over here now, and let's go ahead and fill in this next slot. And let's say it's going to be an x. So now x is a 6. Now, a few of you guys threw out over in BuzzNet, and Nina said 16, didn't you?
Yes.
Yep. And over in the questions panel as well, I'm seeing pretty much everybody saying 16, but it's not. You can see right there, we've printed out, it's 15. This is where we're actually dealing with a postfix instead of a prefix operation. So if I was to jump back over here on the whiteboard, like I said a second ago, this is saying that we're going to increment by 1 after we've already taken care of, actually after we've taken care of the entire line. Okay? So it's like a post operation. Make sense? So if I wanted to see 16, x would have needed to have been incremented first. This is where I could have done a prefix incremental. So if I say y equals y plus, yeah, that doesn't look confusing at all. X, terminator. Let's jump back over here and take a look at what we get. But again, prefix. Let's do this first. So I'm going to come back over here, jump into this little IDE program, and then we will come up here and jump back and say plus plus. Let's run it again. See, you guys are all awesome. You guys that all said 16, you're right. This is what I meant to type a second ago. Yeah, I think. Not really. You guys got it wrong. So, yeah, that's just how it goes. So, again, when you're using the increment and decrement operators, you really need to keep in mind what version of those operators are you using. Prefix or postfix? Postfix means it's going to increment after that line executes. Prefix means it is going to increment first. And Nelson, help me remember something real quick. Didn't in one of our C# classes we run into a very interesting scenario that was compiler dependent dealing with this?
Right. It was when we assigned a expression that contained a increment or decrement operation to the thing that we were incrementing or decrementing.
Okay.
So like x equals x plus plus, for example.
So let's go in here and take a look. I like playing. So y equals y plus plus. So what should the output of this be? What should we print out? Tell me.
Y equals 15.
So we've got a 10 coming in from Mr. MMO Dust. So y, remember, y is being assigned the value of 10. There. Oh, that's horrible mouse usage. And then down here on line 10, we're saying take whatever's in y and put it over in y and then increment. So let's go ahead and build and run this. And we get 10. That's very cool. In C#, that's where we got something completely different, wasn't it? We actually got, was it 11?
I can't remember what we got. It was weird.
It was so weird that
weird.
it blew my mind, because this right here, standard prefix and postfix, is how I've always known the increment decrement operators to function. Like if you're using even Mel, for example, with Maya. Same thing. Using these operators here, you would get exactly what you would think. In this case here on line 10, we are using a postfix operator. So whatever's currently in y will be assigned, well, back to y. So y is not going to change. And then after that line is finished, then as a post operation, y gets incremented by a value of 1. And that works in Mel as well. It works here. But in C#, it just literally destroyed my day. So very simple.
Wait a second.
Huh?
Y started off as 10, and it's now 10. I would expect it to be 11.
But you want to, no, that's post. That was what I was just saying a second ago with it's post. It's after the whole line executes. Then the post of it, then the post operation is to increment. If you wanted to see
Right,
11,
which means no, that should print 10.
no, that's going to print 11.
No, that should print 11.
That's a prefix. So again, prefix operation.
But oh, sorry, in my head, because I'm just getting screwed up from thinking about what happened in C#.
Yeah, it's very weird over there. But this is functioning, which is wonderful, the way it's supposed to. Just be aware, for those of you that have to deal with other compilers from time to time, that when using an increment or decrement operator on a variable that's going to be reassigned back to that variable, you may get unpredictable results. And Microsoft actually has an article about it. Now, I saw where Mandrill says, why doesn't it show 11? Well, here it is showing 11. A second ago, the reason, and let me just show this real quick. If I come in here and do this. Oh, I see what you're saying, Nelson. You're saying, why doesn't, because, right. Yeah, on line 11 show. In my mind, here I am thinking.
Yeah, because.
Go ahead.
That's what I was thinking, because the y would be assigned to y. So the y equals 10, then it should do the increment.
Yeah, that's
after the assignment.
Let me check something here. This will be interesting. So we do still get some weird results here. So if I do this one more time. No. I hate typing on this little keyboard. I just don't have room for the other one. So if I take this right here and let's go ahead and print out Y again, the remote keyboard that is, and wow, it's lost altogether. That's right, MMO dust, yay for coding. So we're still actually getting unpredictable results. Because, again, pre and post. But in Microsoft's article, I don't remember right offhand the link, though it was placed somewhere, I believe, in the member sponsor lounge. But if you just search Microsoft and increment operator, it was something along those lines that I used to find it through Google. The article talks about you should never end up in a situation where you're reassigning a variable back to itself, but you're using one of these incrementers or decrementers, because it comes down to the compiler. It comes down to the compiler. I'm not going to say that, Nelson. It comes down to the compiler for, or the compiler that you're using, and how the designers of that compiler wrote it, and how it handles things. And so they actually say don't do it because their results are unpredictable, which is interesting. Okay, so again, though, back to, and this was, and I apologize, wanting to play here. Like I said, I love playing and experimenting because, again, as Nelson said, this would be dumb. This isn't something that you would do, like you should ever do, really, because doesn't that like do exactly what we're looking for? I'm just saying.
Right.
So, or if I wanted to, what about this? What's that going to do for me? What's that going to print out?
I know.
So this is completely fine. Yeah, so this is going to go in here, and it's going to be a prefix operation. It's going to take 10. It's going to increment it to 11, so it'll print out 11 and 5. And then we still have Y, so we're going to get another 11. So let's go ahead and run this, and there you go, 11, 5, 11. So, here it is working right. Also, as we advance further into the class tonight, you're going to see me start embedding things more and more, like this right here, as opposed to having it on a line by itself. So just letting you guys know. Taking a look over in the questions panel, what is the BuzzNet address to see the messages? I had some technical difficulties in trying to find it. It is buzznet.3dbuzz.com. Okay, so buzznet.3dbuzz.com. Okay, so jumping back over here to the whiteboard, the only thing these are so simple, don't make them hard. Just we're going to plus 1, and this guy over here, we're going to subtract 1 from whatever we're using the operators on. It divides into prefix and postfix. Okay, and prefix means it's going to do it before that line executes. Postfix after the line executes. And then MMO does say, and use the whiteboard to explain why it doesn't work. Microsoft said it's all dependent on compilers, and if you do it, the result such as y equals y plus plus, or actually in that case plus plus y, results in heavens only knows. Okay, so with that out of the way, then any questions about this? If so, throw those in, and I'll get back to the questions in a second. I'll go ahead and move on to the next thing because I'll assume you guys are all being quiet, having a good time, so you understand what's going on. The next thing, this operator is a biggie, and that is the modulus operator. I see so many beginners having a hard time working with the modulus operator, and there's no reason for it to be confusing. First of all, people that hate math, as soon as you mention division, they're like, oh God, they start really panicking. And you remember good old division, right? If I wanted to take, let's see, 9, 10. If I wanted to say 10 divided by 3, how many times will 3 go into 10? 3 times. So, and we're doing this the most basic most basic setup here in the world for displaying this. So 3 times 3 is 9. So 9 from 10, remember this all the way back to elementary school?
Yeah.
Or for those of you overseas, kindergarten. Now I subtract 9 from 10, and I'm left with what? 1. What did we call this back in the day? If we're not going to get into fractional numbers, what did we call this? That's right, Mr. MMO Dust. Jonathan, you slow tonight, brother. We call this the remainder. So this is using modulus, we get remainders, okay? So this is useful in so many different ways. Of course, there are some very interesting things to talk about in the future in regards to performance and ways of not using modulus to get what you're looking for. But for now, it is still a very important operator to know about because you will still use it even if you're trying to write efficient code. There are still places where it just needs to be used. So if I wanted to write something out like, well, first of all, what does the operator look like? I guess that wouldn't be a bad idea to show you. It's a percent sign. So how do we use it? Well, let's just start out with basic stuff. Let's not put in any crazy X's or anything. Let's just say 11 mod 3 equals what? So this is like saying, this is saying 11 divided by 3. Okay, so let's look at it. And so 3 will go into 11 how many times?
3.
3 times. Look at that. So 3 times 3 is 9, 10, 11.
2.
See this 2? It goes right there. It do. Okay? So it's that simple. Now, why is it something of interest to us? How can it help us? We can use it to write like step counters up and down to particular values. We can use it for finding if a number is odd or even. There's a lot of different things that we can use it for. So in this particular case, notice how I've written this out. I didn't use X, Y, I didn't use any variables whatsoever. What I want you guys to do is write me a real quick program. Nelson, go ahead and inside BuzzNet, activate send code and just call it modulus example. And what I want everyone to do is just create their own X and Y integers. Put some numbers in it. And then I want you to print out the modulus. So just, you pick which one you want to be, the dividend and all that good stuff. You can even use the example I did right here. So, all right, so Nelson's got the mod example up. Give you guys just 1 second. I'll pause video so those watching don't have to wait. Okay, we are back, and let's take a look over in the questions panel. Let's see, Nelson, you have it up. What do we have?
Alrighty, so we did get a question. In the event of y times x plus plus, does the multiplication happen prior to the increment? In that particular case, if you want to switch over to my screen, I can type out the actual code that's being asked.
Sure. I'm trying to find the question that you are
I can't.
referring to about. But anyways, here, over to you.
Okay, which screen are you looking at?
I'm now looking at yours, Sarah. Okay, found it. Thank you. Jonathan asked this question.
Well, Xcode?
Yes, we're looking at Xcode.
Okay. Sorry, I'm not used to GoToWebinar on Mac. So the question was something like, so if I have int x equals 10, y equals 20, and then I do something like int z equals y times x plus plus, and then printf. Okay. Can anybody go ahead and guess the output to this program?
Okay. 20. Postfix.
What?
I don't know.
Nina's just kind of mumbling, and
It sounded like something dirty.
I heard I saw a 222. I saw a 200.
No,
I
was
saw like
just saying
220.
postfix.
That's 220. Okay, so I'm going to go ahead and run this. And what we get is 200. The reason we get a 200 is because this is a postfix increment operator, meaning the entire expression is done first, and then it's incremented. So the actual, what this actually translates into is this: int z equals y times x, then x equals x plus 1. So this is the code expanded. So keep in mind that the increment operator, the postfix increment operator, is pretty much the lowest precedence in the order of operations, even lower than the assignment operator. So why doesn't the modulus operator work with float types? Well, the modulus operator doesn't make any sense for a float type. It would be very difficult to do. Yeah, you would get really difficult values out. I don't know. It hurts my head to think about a floating point modulus operator.
Okay, is there anything else, Nelson, over there?
I think that's all the questions.
Was that?
Yeah, I think that's about it.
Yeah.
Okay, let's go ahead and jump back over to my screen. Nelson, if you want to go ahead and kill out the send code button at this point. So let's go
If I
ahead
can find the right mouse.
and make presenter back over here. All right, guys. So, we were all you needed to do, even if I wanted to just leave, what I've got up there right now. Some of you guys, I'll just take this y operation right here, and you could just say, y mod it by x if you wanted to. Or as other people did, and as I did in the drawing, you could have said int r, and I can just come right in here as remainder and initialized it and said int r equals y modulus x terminator. So with what I've got right now, if I were to come in here and print this out, what am I going to see?
No.
1.
All right, you guys are just knocking me over with all these awesome answers.
No, wait. No, I was doing the wrong program.
How many times will how many times will x go into 10? Very good, Mandrill. Very good. Rowdy. Awesome. 5's going to go into 10 evenly. It's going to
Yeah, it goes in even.
goes in there 2 times with a remainder of zeros.
0 would be.
So let's go ahead and run this in there as y being 0. Okay. Now, of course, I'm not using r, so it's going to let me know that I have an unused variable as a warning, and we shouldn't have any warnings, should we? No.
Nope.
So, anyways, wanted to just give you an example of what I was looking for. For those of you that are not participating, come on, jump in, have some fun with this. If you don't know, just try, and then that's how you'll actually start getting good with this. You just have to try with it. Okay, so I'm going to jump back over here into Photoshop, and I have one more set of operators that I want to talk about that we're going to use a lot. And these are our arithmetic assignment operators. Boy, that's horrible. So arithmetic assignment operators. Now, one of the things that, and again, any variables that I draw on the board, let's just stipulate from now on that I have properly declared and initialized them. But one of the things that we find ourselves doing, once again, a lot in code is adding to, taking away, multiplying, dividing values by other values. So if I wanted to come in here and say x equals whatever's currently in x, but I need to step it up by 100. Well, I can use an arithmetic assignment operator here to, once again, kind of write shorthand code to simplify what I'm writing out. And the operators look like this. It's going to be plus equals. We've got a minus equals. We've got a multiply equals. And we've got a divide equals. So I can take, if I wanted to take this line right here and write it in shorthand, if you will, with the arithmetic assignment operators, I could have said x plus equals 100. Same thing. Okay?
Okay.
This makes sense? Piece of cake. And Rowdy, we're still, I saw your question about when's the first break, still just still probably 15, 20 minutes away. But you know this stuff right here, so go take care of the dogs. All right, so again, anytime you're seeing one of these arithmetic assignment operators, you can always just expand it. In your head, just see this as being x equals, so there's your assignment.
X
and in
plus
this case,
100.
what's the arithmetic operator we're using? Plus, so x plus 100. So if we had y multiply equals, say I wanted to double whatever was in y. Again, this right here would be the same thing as saying y equals, there's my assignment, y times 2.
Okay.
So do you guys see how we can start doing some shorthand using these increment, decrement, and arithmetic assignment operators? Can really kind of clean our code up a little bit. We don't have to write quite as much. And for those of you that are just getting into programming, you just look cool, right? You've got somebody that comes around like your girlfriend, she's looking at your screen and you're using all these fancy symbols and she's like, whoa, he's smart. So come on, it's not bad. And I want to start using these as we work our way forward. So we're going to be using them. So hopefully I'm not going to make you guys do anything and turn it in right now, but hopefully, like Nina just did sitting over here beside me, you will at least give a quick play and try it out. So what I want to do now is move over into the world of flow control. Again, if there are any questions, please make sure to ask them over in the questions panel. I'm trying to watch everything on all of the screens. And Exion, I see that your girlfriend works at Microsoft. Oh, man. Okay, so let's go ahead and back over here in Photoshop. Let's bring up our layers, give ourselves a new layer, get rid of this layer. Let's put this back away. Dumb keyboard. And let's kind of scroll up here towards the top somewhere. Okay, so now what we're going to do is we're going to move into a discussion over flow control, and this is going to require a lot of time, but we'll be able to get through part of it before we go on our first break. Flow control sounds all fancy. There are three types, or three kinds of control structures in C programming. And those three different kinds of control structures are, 1, sequential, 2, selective, and 3, iterative. We've all seen sequential. We know that inside main, at our first statement, execution begins. I'm going to start giving you guys cheap versions of flowcharts. That's a statement. It could be printf, it could be x equals 20, whatever. After that statement executes, what do? We execute the next statement. After we execute that, what do we do next? We execute the next statement. And that has been the structure of the programs that we've been writing so far from what we learned in week 1. These sequential instructions result in a fairly unintelligent program. Program's not making any decisions. It's not iterating through code. It's just we start at A and we work our way through Z. So sequential control structure. Selective allows us to bring some intelligence to our application because we can start making decisions. So that is what selective is all about, decisions. And we're going to, so let me do this. I'm just going to say 1 over here. This will kind of keep things a little bit organized, and not 3. I was just kidding. So 2. So some of the things that, the things that we use with selective. If statements. Tonight you guys will be mastering if statements. So we have the simple if statement. We have if else. We have the if else if ladder statements, or some like to refer to it as the if else if construct, because C doesn't actually have an if else if sequence. I mean, it's keywords that are put together. It's an if else and an if. So so I'm gonna write it like this: if else and then if. And then we've got one more, and we're not going to be looking at this one tonight because of time, but for anyone that's interested, I will definitely make some time at some point to go over, just like the pointers lecture. Nelson, I still would very much like for us to schedule a pointers workshop for those that are interested in coming out and hanging out through 2-3 hours of pure pointer abuse. Because
sounds like fun.
I think it'll be a lot of fun, because next week we're going to be getting into Objective-C finally. You'll know enough C that we can finally move into, this whole new crazy looking world. And trust me, it's going to be a big shift for some of you guys, a very big shift. But, for those of you that want to learn things like pointers in more detail than what we're going to provide in this course, I want to make it available to you. This other keyword that I was talking about is switch. So the switch statement. Now, we're not going to look at the switch statement tonight. I'm trying to cram as much stuff as I can in for the 4, which will probably end up being 5 or 6 hour class. But we will be looking at if else statements tonight. So that's selective. It's all about choice, making a decision and deciding what code are we going to execute. And if I was to draw that out in kind of a block diagram way, you guys really need to see my work environment right now. You would so understand why I'm struggling. So here's 2 again, but we're cruising along. We're having a good time. We executed a statement. We executed another statement. Oh, we're so cool. Oh, what is this thing? We've got to make a decision. Flow control, ladies and gentlemen. Now from here, if it is, let's say that if the result is, I'm just going to say yes and no for now. We'll get into true and false shortly. Yes and no. So if the result was yes, is the sky blue? Yes, today it is. Then we're going to execute. And look at this. We're executing. We're executing. Sweet. If the answer is no, we're executing a statement. We're executing a statement. We're executing a statement. But then, no matter which way, at some point, we continue just executing statements again. So do you see how right here, what I've actually drawn out is an if-else. So if the answer is yes, we're going to do this section. Otherwise, we're going to do this section. And then once either of those two sections are done based off of what the answer was, we will continue with execution. Now, if I would have just drawn no, come down here like such, that would have just been a regular if statement with no else. Because it would have just said, if the sky's blue, let's do this. And then continue on. There was no otherwise, let's do that. And we're going to be looking very closely at if and else very shortly. We'll spend a little bit of time with if, and then we're going to talk about more operators. I'm going to load you guys up on way more operators than we looked at in the C# 101 class tonight, which, hey, is fun, in my opinion. Okay, so that's what it looks like. Now, I know, as Rowdy Bull just said, use paper on class night. That's right, sir. Lots of notes. Again, designed for our beginners. So there are no questions really pouring in.
Nope.
I mean, Jonathan's awesome with his a little more techie questions, but our beginners, I have to assume right now that you guys are rocking. You guys are thinking, this is so easy, or you're laying with your head kind of kicked back, drool coming out of your mouth, and your eyes have glassed over. And I hope we're not at that point yet. Okay, sweet. Nope. Jonathan, Jen just said she's hanging in there. That makes me feel fantastic because she's doing good. Oh, Tokyo Drip, thank you, sir. Jason, this is sinking in. Oh, you guys are making me feel great. Good deal.
Chris has a question.
Okay,
Chris. Statement, actually.
Very similar to PHP in some ways. Yes, sir. And that's all I'm going to say. I'm waiting for Nelson to come on and do a gigandous sigh.
Yeah, that's not the super stuff
so,
on PHP.
Moving on from here, let's take a very quick look at 3. So again, high level, and then we're going to start dropping down.
Iterative.
And Mandrill said, no drooling yet. And I try to structure these simple 101 classes that I teach where, you know, they're so basic that you could bring your 6-year-old in and give them a mic and say, let's rock and roll, and they'll probably school you because they're young and, you know, their
brains are sponges.
Yeah, exactly. They're thinking more freely and faster. So anyways, the crying's coming shortly, Jen. So iterative. We need the ability to loop. So what does looping mean? I need the ability to repeat code over and over and over. What if I wanted to go through a list of students and take each student and average up their test scores? And so when we get to the very end, we've got all of the students' final averages. I'll need to take a list of students and loop through those students. I wouldn't want, well, first of all, how could I possibly go in there and hard code in, watch this, students. Let's say that this class, we've only got 10 people in. Fortunately, there are more than 10 people in the real class right now. But let's say we've only got 10 people in there. Do I really want to hard code that code that's going to say, let's calculate the average of student 1? Let's calculate the average of student 2. And let's say that each of these calculations involves 2 lines. So that's student 1. This is 2 lines of, these are 2 statements. Okay, so now I've written 4 statements. Good. We're all counting great tonight. Fantastic. So student 3, 2 lines. Wouldn't it be a lot better if I just said, here are the 2 lines used to actually calculate an average, and then I want these guys, I want to just continue doing those 2 lines over and over and over, but for each student. So instead of writing the code over and over and over, you just write it once, and you're going to loop through it. Now, we have another very interesting problem with what I've written here. Let's say that I am just completely dumb, to use Nelson's favorite word, and I hard-coded in 10 students, and I did 10 manual averages of all of the students' test grades. And now let's say that we're going to use this program again. We hired company XYZ, consulting service, to come in and write this awesome company for us. And they said, how many students do you have? And I was like, I've got 10. They're like, all right, so here's your program. And we had 10 students.
And you never went back to them again.
And we used the program, and the program was glorious, and I hit a button, and I had everyone's averages, and I went home early and took my family out to dinner, and I was happy. It's like, I love XYZ. They're good. And then next semester came around, and I had the class again, and now the class had
30
students in it. was like, all right, we got 30 students. And so, you know, I'm not thinking about XYZ, right? They're an awesome consulting firm. They wrote that program that in semester 1 I used, and it was awesome. It did its job. So now here, I'm not thinking about them. I teach my class. I do my thing. I give out tests. Now everybody's turning in their tests. We're now at the end of the semester. I go to run the program. I only get 10 averages back. I'm like, what's going on? And so Nelson said I never contact XYZ again, but Nelson's wrong. He's forgetting how clients are. Clients are going to call you back. Oh my God, they're going to call you back and scream, the program is only calculating 10 of the 30 people. What's going on? Of course, unfortunately, that's what was in my mind to say when I called them back. But when I called them back, I got an out of service message from the phone company because they were dumb and they hard-coded stuff in their code. Nelson and I both had to deal with a programmer's code lately, without going into any specifics, Nelson, a programmer's code lately who had hard-coded stuff, addresses and things like that, into the actual software. Thank heaven that I had the source code to go back into it. Do not hard-code stuff, or I will get a plane ticket to wherever you are, and I will bring a big, nasty smelling dead fish and smack you with it, because hard coding stuff is bad, okay? This is where we would want to create a loop. This is where we'd want to use iterative flow control. Okay, so hopefully you guys have an idea, those of you that are completely new, because I heard Nina over here by me as I was working my way through the student example go, oh, and that always makes me feel good when I hear a student's light bulb turn on. It's more like feel their light bulb turn on because it's the warmth of it. So with flow control, we're going to be looking at iterative flow control. We're going to be looking at 3 things tonight. We're going to look at while loops. We're going to be taking a look at do while loops. And then finally, we're going to put a little dot beside these. Yeah, it looks a little sexier. Now we're going to be looking at the final thing is going to be for loops. Okay? This shall give us the power of doing iterative flow control. Okay? So that's what we've got coming up. Now we're going to kick things off after the break, because it's we're right at break time. We're going to kick things off after the break, taking a look at if statements. We're going to look at very simple if statements, and then we're going to journey into the world of true and false. And what does that really mean when we're talking about the C programming language? And because that's where stuff gets fun. And then we're going to go from there into comparison operators and logical operators, and I got all sorts of stuff planned for you guys. Nelson actually saw my lesson plan earlier today, and he's like, "Are you dumb?" So that's his favorite word. I mean, that's it. He says it to the pizza guy when he shows up at the door with the pizza. You dumb. Here's your $20. So anyways, it is now time to take a break. Nothing to do on this break, so I can say 10 minutes, and then let's start right back up. We do have a lot of stuff to cover tonight. Stretch your legs, chat amongst yourselves over in the BuzzNet if you'd like. I'm going to grab myself something to drink, and then I'll be right back to, join in the chat with you guys. So right now, let me go ahead and hit pause. Welcome back, ladies and gentlemen. I hope you were able to use that break to catch your breath and kick back and relax a little. But now it's time to start turning up the heat a little bit. We're going to be looking at our first actual statement that will allow us to modify the flow of our code, and that is the if statement. And Nelson, pull your mic maybe down a little, or I feel like I'm watching a rated R show on the internet. You're like all that sexy breathing and all. Yeah, thank you, sir. That mute's so much nicer. Okay, so let us first come back over here and go ahead and bring up the a new layer, and I'll go ahead and hide this out. And having to kind of hunt around on the old keyboard. You gotta hit that function key. All right, so. Do a little dot up there just so undos don't bite me. So first thing I want to talk about, we're going to get into the world of if statements. This is going to be a very simple if statement. So first thing I want to look at is syntax. So remember, with syntax, we have our set of rules that we need to follow. And so we have rules on how An if statement needs to be expressed for the compiler to understand what it is. And it's so straightforward. Check this out. If. Bet you never saw that coming. Open parentheses. Expression. Close parentheses. Statement. It's a statement, so we got a terminator at the end. All right. Simplest form. An if statement, expression, and a single statement. First thing to take note of is the indentation, the tabbed space that I am using right here. Remember last week when we were talking a little bit about formatting? Remember how I had said with formatting that having things indented allows you to quickly just follow that indentation all the way back up to the first dude that's not, I said dude for an if statement, for the first dude that's not indented, and you can kind of look at it as, hey, those guys belong to that. Oh, that's the deal here. Now, Jonathan asks over in the questions panel, are you going to require us to use open and close brackets, well, I'll pretend you said braces, on our statements? And we're going to be covering all of that. With a single statement, I'm not going to require you to use them. It's not at all. Okay? So, but we will be getting into compound statements and or what's also commonly referred to as blocks. Okay? Nice try, Jonathan. Okay, so very simple if statement. Now, expression. What's expression? Nelson, you get to answer this one. What's an expression?
An expression
Give me a single word if you can.
Something that evaluates into a value.
Okay, very good. The single word I was looking for is it's a value. But yeah, it evaluates all the way into a value. We've seen literal expressions like x equals 5. 5 is an expression. It is a value. We've seen x equals x plus 10. X plus 10 is an expression that evaluates into a final value. So notice we have this expression over here. So we've got something that's going to be evaluating into a value. Well, when dealing with an if statement, and as you start talking to savvy programmers out there, you're going to start hearing the word, again, this is for those of you that are completely new to the programming world, true and false. So common way to talk about this syntax here would be, well, if this is true, we're going to do the statement. Okay, so that's how we can look at this right here. If this expression is true, then we're going to do this statement. But here's the question of the day, the most awesome question. What is true? In some languages, true and false are very defined. They're bools or booleans. A little different here in C. It's going to make this a lot of fun. Let me see what question just came in. That is one of the things that has confounded me so much about this. So an expression is a condition. No, sir, Marvin. Great question. An expression is something that can be evaluated into a value.
Right. So like x plus 5 is an example of an expression.
And after the way I've got this all planned out, I think it's going to make a lot of sense to you because we're going to do a couple of neat things outside of if statements to help really knock home the understanding of what an expression is. Okay? Sweet. Okay, so what is true? Well, here's the cool thing about C. We can't say what is true. We can, but we really have to start out with what's the opposite, Nina, of true?
False.
That's right. So that brings us up to what is false then? False, this one we can answer. False is 0. So understanding what false is, now we can say, oh, well, let's take a look at what true is. So Nina, going by what we said a second ago, using opposites, what does that mean true would be?
Well, true would be something more than 0, I would imagine.
Ha 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 ha. How about this one?
Close.
Close. It's anything other than 0.
Okay, so it's anything but 0. Okay.
So anything, check this out.
Because it could be negative something.
That's right. That's true too. So this right here, is an operator that we will be covering shortly. This is called the not operator. So anytime you see me use an exclamation point, I can say not. So anything that's not 0 is true. So if I was to say if 1, then we're going to, all right, guys, let's pretend I've put a macro in place. Oh, okay, hang on, no, let me not say that. I'm going to do pseudo typing here, okay? So pseudocode. So just pretend in your head that I'm typing out printf. We all know what printf looks like. Mm-hmm. So let's just say that I'm saying printf, and I'm going to say, I'll just say printed. And then printf, and then I'll say execute it. Now, I'm making stuff up, bear with me. And let's also stipulate there are terminators and \n's in there as well. Execution, flow control. We come down here, so we've been executing along, computer's having a good time, and now comes down here to the if statement. The if statement takes a look at this expression. If the expression is true, it is going to execute this line of code that's indented. Now remember, the indentation is for us, the programmers, for readability. It does not need to be indented. And those of you that are new to programming, you will end up burning yourself because of indentions. Because if this line wasn't indented, you may think to yourself that, oh, that's not part of the if statement because it's not indented when you go back and look at your code later. But that's important. I want you guys to, we've indented it for readability. So we know that if what evaluates in this expression, which in this case is the literal value 1, if it's true, then we're going to execute what's in this if, which is this one line. Notice I have the other line not being indented. Okay, so this guy right here, not indented. He's actually lined up with the rest of the code that's running on down like so, right? This code is going to execute no matter what the if statement, if we're true or if we're false. It's after the if, and we just continue with execution. So now, as the computer, let's think like the computer. So we've executed the last line. All right, we come down to the if statement. All right, well, that's fine. It's cool. Okay, let's jump over inside our parentheses. I'm going to check out this expression. Is the expression going to be true? Well, what is true? Anything other than 0. Is the value that's currently inside of our parentheses, is it something other than 0?
Yes.
Oh my good God, I did not see BuzzNet light up with 5,000 yeses. That was the easiest question of the entire night. Nina got it. She gets the cookie.
Woohoo,
you guys are slow.
Cookies.
That's right. 1 is not a 0. That means it's true. So this evaluates to a true. So I'll just say is true. Jonathan, we're not doing C# right now. Now, since it's true, we will execute this line. So we will see printed. If I come up here and I put a 0 in here, and now execute the program again, what happens? What do we see written out to the console?
Executed.
We just see executed. Absolutely. Let's go ahead real quick. I want to jump over here, and if you guys want to follow along now, follow along, especially those of you that are new, so that you've gotten your hands dirty. And very simple stuff. I'm just going to say if 1, print f, printed, woo, and new line. And then let's go ahead and down here I'm going to say print f, executed. Except for, let me actually put a \n in there like a good boy. So same thing, right? I put the extra line of white space in here just for readability. See how that looks a little jumbled to me? Okay, and real quick, Marvin just said over in the questions panel that it sounds like a condition. It is a condition. Absolutely. But I'm really getting down to the nitty-gritty. The nitty-gritty of it is simply that the compiler is just looking for, is it a 0 or is it anything other than 0? At the end of the day, that's all if statement is looking for. You know, I sure don't mean to take out all of the amazing magic behind Booleans and all that good stuff, because I kind of am. But that really is, at its most basic form, exactly what it's doing. Is it true or false? And remember, true or false is just our nice way of saying, is the condition true or is the condition false? But all it's doing is looking at an expression to see if that expression is a value other than 0 or 0. No kidding. Okay, so in this case right here, since we've gone in there and we've put a literal value 1 in, we're going to see printed written out to the console, and then executed is going to be there no matter what, because after we're done executing line 9, execution continues statement by statement in a sequential fashion for the rest of our program. Let's run it. So everybody run their little program. All right, we should see printed, executed.
Yay!
And then back over here to questions panel. Marvin, you and I got a special thing going tonight. I love the questions. Thank you, sir. Is the if statement looking for that all the time? Absolutely. It really is that simple. If statement just wants to know. If it's not 0, we're going to execute what's in the if statement. And then the else is what we'll execute if it's anything other than 0. But we'll get to else. That's getting ahead of ourselves. Okay, so you okay, Nina? Yes. Oh, don't worry about marking stuff over there. I'm tracking all of that because I know the desk is quite a disaster at the moment. All right, Exion, I'm gonna help you out in just a minute with that because we actually have something available for us in the standard library. And for those that are watching this video later, over in BuzzNet, Exion asks, could we make variables named true and false and make them 1 and 0? I really like where his head's at. And so do the writers of the C standard library. So they beat you to it. And also, just to point out, a lot of compilers out there will also understand true and false capitalized as constants as well. That's kind of like built in. But we're not going to be using that. Okay. So anyways, all right. So let's go ahead and do the same thing we looked at back over on the whiteboard, and let's change this to a 0, not an O. What is that all about? A 0, MacBook. User operator error. Okay, so if 0, well, remember, we already said anything other than a 0 is what will cause the if statement's code to be executed. Otherwise, in this case, we're just going to simply continue on. So let's run it. So Command R, look at that. All we have is just executed. We completely skipped the stuff inside. Let's do one more. I'm going to put a -1. What is this going to show in the console when I execute?
Printed and execute. Yay. Ouch.
Okay. Nina just said printed and executed. Both lines. Very good, Jen. Let's go ahead and execute and see what we get. Very good. Printed and executed. Again, anything other than 0 is true. And Wizzykin, I totally agree. Man, that's some bizarre stuff. But yeah. Jeez. Oh, we're going to be looking at now Wizzykin asks, you can put commands inside of the if statement, and it runs yes, anything that at the end of the day is going to evaluate to a value. Print high. Yeah. Well, all right. Hang on. We'll get a little bit more involved. Let's not get off track at the moment, because we got to start understanding some stuff about returns and all. Back over to Mr. Marvin. Let's see. Marvin says if the if this is true, then if this is true, this is the simplest anyone has ever explained it. No pun intended. Just made my first programming joke. Yes, you did actually. Very nice. I have been confused about that expression section for the longest. Awesome. Hey, you know what? You just made my night, because that means somebody now got something new. That makes me feel great. So, Jonathan, don't get ahead with the not operator. I am introducing that here in just a few minutes. Okay, so we've taken a look at our code Very simple stuff. Let's go ahead and jump back over here to the whiteboard. And again, as far as how this looks blocked out, if I was to say, let's say int x, and then I want to say x equals 5. Then I want to say if 1, hit the dumbest if statement in the world, then we're going to say print hello or whatever, right? And then I'm going to say x equals 10, and just keep on with whatever random amazing code that I want to write today. The way this looks, if we were to check that out, Nina, I'm not even touching my screen.
How in the world?
It just hung on me. The way that would look, blocking it out, very simple block diagram. So this is going to be our int x. And this is where, again, see our statements, x equals 5. Now we're going to look a little different. Now I'm just gonna put a 1 there. I could put a true there. Generally, it is a condition like x greater than 5, and so you could write x greater than 5 in here. But in this case, it's just 1. So if the answer is yes or true, so I'm just going to say yes, though we're about to really start using all of that, then we're going to print some stuff out. And then we just continue with our standard execution, where I'm now going to say x equals 10. Back up here with no. And I can just draw the line over to here. So you see how we skipped. This is the big thing to realize. We skipped this section. If the result of the expression is 0, if it's false. In this case, though, we've hard-coded it. There's that nasty word, hard-coded. We've hard-coded it to always be true. But since from time to time I will be drawing little diagrams for you, I wanted for you guys to see how I would be drawing my if. It's going to be a little diamond, and I generally put my little expression inside of it, whatever it may be. So let's go ahead and undo all of that. And let's go ahead and talk about true and false real quick. So we've defined what true and false is as far as the C compiler understands it. False is 0, true is anything else. Chris says, if, so question over in the questions panel, if what is 1 or true, oh, that's just random code that I was just writing down just to make a snippet of a program just to show execution. I just wanted to show the flow control with a very simple flowchart. That's all. Okay, so sorry if I confused anybody there. All right. True and false is something. These are words that we use in most programming languages. It just makes sense. You know, we could say if, let's say I make a variable called sick, and I'm going to determine if a person is sick. I could say if sick. If sick is a Boolean type, then you could just simply say sick equals true. Then if I said if sick, then, oh, well, we know true. Now, how do I gain access to true and false? Because we don't have that available for us. Now, of course, we could use a preprocessor directive and we could define it ourselves, or we could take advantage of true and false that has already been provided with the C standard library, and we can do that by including, and we all saw last weekend how to include. I was wondering why that wasn't actually moving. I was using the wrong keyboard. We can include the header file. I'm not going to write out the whole include word. We'll do that in a minute for real. stdbool.h. And this gives us access to a true and a false that has been predefined for us already. So let's go ahead and jump back over to our code real quick. If you guys would like to follow along so that you've done it yourself, notice I'm all the way up here on line 2. I'm now doing a pound include, and now what I'm going to do is tell it that we're going to be using the stdbool. Look at that, it's already, IntelliSense is already helping me out here. How friendly. And then let's go ahead and end that off. So bool, STD, so the question came in from Chris. What does that literally mean, STD bool? This is a header file. Just like if you guys recall last week, we said that the stdio.h file was the standard input-output header file, and it is what gives us the ability, it's what makes our program aware of what printf is and scanf, those two things that we used last week. Because this is including this header file, which contains a bunch of protocols, a bunch of function protocols in it that tell the compiler what printf, what that function looks like. And if you recall last week, I had also said, we didn't focus a lot on this, but I had said every time you compile a C program, the standard C library is always compiled with it, unless you go in and you make special concessions with your settings to not include it. But even then, we still need to tell our, in this case, our file that we're in, we need to be able to tell these functions what printf looks like. And it has been defined or declared in the standard IO header file. Now, stdbool, we start talking about bool, that's short for Boolean. And when dealing with Booleans with code, we're dealing with, well, Boolean period is a 1 or a 0, or true or false, or an on or off. It's a two-value thing, okay? So when we're dealing with code and we're talking about bools, we're generally referring to true and false. So inside the bool, or the stdbool.h, this is where we're going to have defined for us true and false in lowercase. So we look nice and happy, and now I can actually do this. Yay, true. I can just type out if true now. And looking over here at WizzyKinnon says, this is over in BuzzNet, so I'm trying to handle questions from everywhere. He says, this seems odd to me that bool isn't a primitive type. Correct term? Yeah, it's just how C was. Well, go ahead, Nelson.
Yeah, C is an old language.
It's an old language, and it's just how it's been forever. Anything you want to add?
And for well, just a clarification for people who might not know what primitive type means. Primitive type is a type that's built into the language. For example, an int or a float are both primitive types. And in some languages, a Boolean is a primitive type as well, meaning there's first-class support for it in the language itself.
First-class support. Love it. But that's absolutely correct. Okay, so now we can say true, we can say false. And from this point forward, I am now allowed to use the stdbool.h header file so that I can use true and false. And we all know where it now comes from. Okay, it's just part of the C standard library. So let's go ahead now and jump back over. If at any point you guys have questions, man, be like Chris and Marvin. You know, just jump in there and ask them. And I'll just continue on, though, until I see anything that comes in. So the next thing I want to talk about is I want to look at some more operators, because now I want to start flexing our muscle a little bit. We know how to use the basic if statement, but what types of checks can we do? Now we're going to get back to Marvin's word, you know, condition. It looked a lot like a condition to me. Well, let's see if we can set up some expressions that look like, you know, a conditional test, like if this is greater than that, or if this is equal to that, etc. So these are called comparison operators. And we've got, let's start with the first and most important one, an equality check.
Yeah, this will be a fun one.
An equality check means if I say int x equals 5, Terminator, and then I want to check to see if whatever's in x is currently 5. So if x, now here we go, I'm going to do this, equals 5. And as a matter of fact, watch this.
Actually, change it to 0.
Yeah. Well, I was going to actually change this up here. I was going to make this a 6. So then, you know, you might be looking at this, and you think to yourself, oh, well, if x is equal to 5, Well, no, it's not. So we're going to, whatever code is to be executed here, we're going to skip that and continue with regular execution. What we really have going on here is what? What is this operator right here called, ladies and gentlemen? I saw it a second ago. MMO Dust gets the golden star. This is an assignment operator, period. Okay? So it assigns 5 into X. So we have a value, don't we? What is the value of our expression? Value's 5.
5.
Is that true or false?
That would be true.
That would be true. So guess what? Our code in here is going to execute, and if we're not paying attention to what we're doing, and I have seen experienced programmers do this with more complex looking code, but they accidentally put a single equals there. They put an assignment operator in, and they are expecting, based on the conditions of the program by the time this if statement was executed, that the actual code that needed to be executed if the expression was true, they expected it not to evaluate or to run, but it would run. And so then they start trying to troubleshoot what's going on. So you can see right now how this can get us in trouble, because in this case, we know in our heads, and again, very simple thing. Hey, Blender, and somebody is a tweet. Hi, guys. All right, so anyways, and for the questions that are coming in about, I'll get to those in a second, because that's actually what we're talking about right now. That's the lecture. So in this case right here, though, so we're just doing an assignment. We know X is 6, so just looking at the code, if your brain's like, on autopilot, you're just cruising along and you're not really paying close attention, and you look at it and you're like, is X equal to 6? Well, no, it's not equal to 6 or 5, excuse me, because I know at the moment that X has a 6 in it, and 6 is not equal to 5, so we should just skip over whatever's in it. Perhaps what is in here is you want it to show off to your friends, and you've done a function call to something that's going to format your hard drive, right? Oh, because you're so elite and all that good stuff. Then you run your little program, and your hard drive starts formatting, and you're like, huh? What happened? Okay, yes, I'm being a little excessive, but I'm just trying to make the point here that what we've done is an assignment. This is not an equality test. To do an equality test, the operator's different. What we need to do is come in here and use 2 equals. 2 equals, this is equality, an equality check. So to correct my if statement, Nina, what would I need to do?
X equals 5.
You got it. This no longer means an assignment. This says we have an expression that we need to evaluate. This is still an expression. Even though you look at it, you might think it's a condition, and you can say that. Heavens knows I have in the past, but it is an expression, and it does evaluate. X equals 5 evaluates to 0. Is that true? How could that possibly be true? Well, let's come over here. Watch this. If I jump over into code and come down here and I say, let's just jump up here actually. I'm going to say int x equals, what did I put over there? I put a 6. And then we're going to say, I just want to do okay, I know how I want to do this. Sorry, I'm just thinking of how I want to make some stuff up. So int y equals, and I'm going to now initialize y by saying x equals 5. Okay. So now we only have a warning. Our warning is going to be, hey, you got this value y, it's not been used. So let's go ahead and say printf y equals %d \new line, and then let's go ahead and tell it that we are currently using whatever is in y. Now all of our warnings are gone. This is still nothing more than an expression that evaluates. Okay, evaluates to a value. And this value that it is going to evaluate to is x currently contains 6, and 6 is not equal to 5. So it will evaluate to 0. Let's go ahead and execute and run and test. Y equals 0. Okay? That's very important to understand. So let's go ahead and jump back over real quick to our whiteboard. So that's an equality test. And we now see that these expressions, they don't, all because we got the parentheses around them, and it's not like they're this special fancy conditional thingy-majiggy. They're just expressions that evaluate. That's all, to a value. So let's go ahead and move on to a few more of these comparison operators. Less than or equal to. We also have a greater than or equal to. We have just your regular less than, your regular greater than, and then one of my all-time favorites, not equal. Okay? So for those of you that are taking notes, go ahead and throw these down. These are your comparison operators. And looking over at the questions panel. So Marvin says, so in that example, x is not equal to 5, you said. So yeah, back over here in what I had actually coded out, we set x, we initialized it to a value of 6. And so what is currently in x is 6. And we're not doing an assignment here. We're doing is equals or an equality check to this value here. So is 6 equal to 5? And the answer is no, it's not.
So then it's false.
So it's going to evaluate to a 0 because that's what false is.
0.
No worries, Marvin. No worries. Okay, so let's go ahead and jump back over here into Photoshop. So these are our comparison operators. But yeah, the whole, using these guys, using these expressions, you can end up with some code that could really look tricky, such as what, and don't code this out, just tell me what do you think x would be. So if I said x equals, well, let's just start with this. X equals 10, Terminator. X equals x greater than 5. If I was to print out x, what's x going to be?
It's 10. Wait, hold on.
See what I mean? This starts playing with your head a little bit.
Okay. X equals 10. X equals...
Well, let's just take a look at this. We're actually using a comparison operator. So we're going to evaluate to more or less a yes or no. To a 0 or a 1 is what we're going to evaluate to.
So then it would be 1.
So is x greater than 5? Yes, it is. If it's yes, that's going to evaluate to a 1, which is true, because remember, anything other than 0 is true.
It's true.
So when we're looking at expressions and evaluating like this is what we end up getting. We get a 1. So in this case, if we were to look at x is going to be, after this line is executed, it's going to be a 1. So what do we have if we have, let's say, x equals 20? So what do we have right now on the next line if we looked at x? What is it? 20. Trick question. Haha. Okay, So now moving on, because we just put 20 in x. So now if I said x equals x less than 100 plus x greater than 5.
Oh.
What is x equal to?
Okay, so it is.
Dementis, don't put a question mark there. Say it with confidence.
It's 2.
Come on, I'm waiting for Dementis to say it with confidence. Still waiting. Yes, yes, with an exclamation point. I love it. All right. For those of you that are going, very good, Mandrill, and I love it, all caps. So let's break this down and look at what's happening. We're going to execute, or the computer's going to look at it from left to right. So, and we have these parentheses here. So we're going to start by evaluating here, and then because of order of precedence, we've got to take care of all of our parentheses first. They're much higher than the plus is. So looking at this, is x currently less than 100? Come on, what's in x? 20.
Yes.
That's right. Is it less than? Yes. If we say yes, we have to put a 1 down.
1.
So let's go ahead and carry our little plus down here. All right, we know what's in x. It's 20. I've already said it 1,000 times. Is 20 greater than 5?
Yes.
Yes, it is. So if I was to put these two guys together,
2.
add them up, I know, I told you guys we were going to get into some complicated math. I wasn't kidding. 1 plus 1 equals, and you know what, Dementis? You're absolutely right. You get the star. If you said it with pride, you said it loud. It's 2. Okay? So the thing I'm really trying to drive home here is don't look at these really as a conditional type thing. Look at these as what they are. They're expressions that are being evaluated. And when we're dealing with expressions that use these comparison operators that we talked about up here, we're evaluating to one of two values, a 1 or a 0. And we saw we didn't even need to use them in if statements. You can just use them outright. So that's a really, really important thing to grasp. Nelson, you've been quiet for a while. Is there anything you want to add to this before I move into the next set of operators?
No, not particularly. I mean, you've covered this in actually rather
Are you trying to say
lots of detail.
You saying I've beat it to death? I'm just trying to make sure people understand.
Oh, no, it's good. It's I think it is really important for people to understand that conditional operators are really just that. They're binary operators. What I mean by a binary operator is it takes two operands. So it's no different than an addition operator. It's just these operators do different things that happen to coincide with how if statements work.
Exactly. Or not even just if statements. Because the construct of an if is, if it's anything other than false, we're going to execute this next line or block of code. So using the comparison operators is just going to result in an evaluation between our two operands to a 1 or a 0. Now, Marvin had a question for us over in the questions panel that said, that proper distinction is very important to make. In what situations can thinking of this as conditions trip you up? It's a good question. I still look at if statements and I still look at the expression inside as a condition. So as far as how would it trip me up, it really wouldn't. For somebody that's new to coding, if some coder was using some logic that used one of these comparison operators in a non-if statement or outside of any kind of iterator flow control, like for statements or whiles, etc., then this could possibly trip them up because they might be thinking to themselves, X is greater than 5. Oh, they left out the if and it's all messed up. And then that's probably the only place as far as a trip up. But as for looking at an if statement and you think condition, I still do to this very day, and I'm sure I always will. But anyways, I just wanted to beat the horse over and over and over to help everybody understand what's really happening with this. Okay, that's right, Nelly. I forgot your ponies. But now, so we've turned up a little bit of heat, just a little. We've given ourselves some comparison operators that we can play with now, and this allows us to start making our if statements a little cooler. But man, it's a crash course. We got to look at more than that. I want to make this even more interesting by now introducing you guys to logical operators. It makes what we can do with if statements even cooler. So logical operators. Yeah, I love these guys. I use them all of the time. Let's start out with the simple one that you guys have already seen a couple times. It's the exclamation point, which is basically, here's how it's pronounced. Not. Simple enough. So it acts like a toggle. So if something is, check this out. Here's how the toggle part comes in. If it's not true, it must be
false.
False. See, you look at that. Nina just did a toggle.
I toggled.
Nina, if it is not false, it must be
true.
Oh, another toggle. What? I love it. So there we go. Very, very simple. That's not, and we're going to use not in some interesting ways coming up very soon to help drive home some logic points. Now, I'm sorry, WYSICAN, no Borat accents. Okay, so not. So now let's look at the next one, which are going to be these two ampersands. And this is pronounced and. So if I wanted to say, if the sky is blue outside and I feel good, then we're going to do something. That is an and. And then the next logical operator I want to that I want to introduce you to is the or. And as Ashley just said, railroad tracks. Yeah, these are your two pipe symbols. Over on your keyboard, it should be above your enter key, unless you are living someplace other than the United States, and then heavens knows where it may be. So shift, and then, so it's on our backslash key, and that is the pipe symbols. So two of those, this is pronounced as or.
Or?
So now, for those of you that have had fun in math classes in the past, let's see if we can walk down memory lane here. Let's talk about some truth tables real quick and see how all of these fun things work. So we're going to start out with truth tables for the not operator. So let me see. Table starts with a T, not an A. I'll say tab. Table for not. So let's see. Jonathan said, programming in general question, why do languages simply use a single not operator but dual and or? Jonathan, that is a really good question, sir. Unless Nelson knows, I don't.
Well, think about it. The bitwise.
Yeah. Good enough. Go ahead and explain it.
There's two other.
Jonathan.
Yeah, there's two other operators, types of operators that are similar to the logical not and nors, and those are the bitwise and nors, and those are just single ampersands or single pipes.
Right, and that's something that we're not going to be getting in the crash course, but we can always throw that into a to workshop, because that's a lot of fun when you start playing with, which means then we get to also introduce XOR and some other cool stuff. But and bit shifting and yeah. Anyways, so back on track. That I totally forgot about that. I'm on a roll right now, man. You messed up my mojo, Jonathan. Thank you, sir. All right. So anyways, continuing on. So let's go ahead and look at this truth table. So what I'm going to do is I'm just going to say A and not A. That's just how I'm going to refer to these guys. It could be X. You know, we could say X. A is going to contain, well, whatever I put here. So let's say A contains a 1. Well, I'm going to actually start using true and false. That'll help a little bit here. So I'm going to say if A is true, then what do we have for not A?
False.
False. It's a toggle. So if A is false, what do we have for not A?
True.
We have true. Now let's jump down and look at another truth table. Let's not jump down. Let's jump over here and leave that guy visible. And now let's look at truth tables for and or. There we go. So here, I'm going to say A and B, or we could say X and Y. It doesn't matter. And I'm going to say this is just a kind of a common representation for a truth table. A and B, and I'm going to show you A or B. Let's take a look at how this works. Very, very straightforward. If A is a true value and B is a true value, then the evaluation that happens here is to true, because that's what this and means. This is saying that if both of these guys evaluate to true, the result of this expression is true. So since A and B are both true, it is true. So now let's look at or. Or simply says, and Nelson, go ahead and mute again, just to help cut down on some of the noise. Thank you, sir. So with the or, we're simply saying if A or B is true, this expression will simply evaluate down to a true. So what are we going to have if both A and B are true?
True.
Absolutely. Tokyo Drip beat everyone, and he's still having to deal with lag. Awesome job. So now let's start switching things up. So let's say, what if A is true and B is false? So if we're looking at the AND,
Be false.
that's right. We have a false. Good job, Tokyo's all over it. So a stealth coder. That's because, remember, with the AND logical operator, both A and B has to be equal to the true for a true to be evaluated. So now let's go ahead and switch over here, or to be the result of the evaluation. My bad. So A or B. So what do we have here?
That would be true.
This would be true. Very good, Jen. Absolutely. Because if one of the two is true, the evaluation result is going to be true. And so that's what we've got. So let's flip A and B around. So false, true. So we're going to have what are we going to have over here for an AND?
False.
That's right, false, because they both have to be true. And then let's jump over here to the OR. What do we have?
True.
True, because one of the two is still true.
True.
And then finally, let's go ahead and look at false and false. So false and false.
False.
That's right. Because one of them has to be, well, both of them have to be true for the AND to give us a true. But now over in the next one, what do we have?
False.
False, because one of them, that's why I was getting ahead of myself, one of them, A or P, has to be true to evaluate down to a true. So this is the a basic truth table for using the NOT operator so that you can see how it is a toggle, and looking at the AND and the OR operators for us to see exactly what would happen when comparing two different things against one another with the AND and OR operators. And Chris asked over in the questions panel, is that 2 exclamation points or 2 pipe symbols? And it is the latter, sir, or it is 2 pipe symbols, not 2 exclamation points. Okay. So, as Wizzykin said over in BuzzNet, which is true, sometimes the 2 pipe symbols looks like it has just 2 lines for each other. And it's, and that's absolutely true. But that's what the pipe symbol actually looks like right there. Just, well, one of them. And then we put 2 of them together and we have this. All right. Ta-da. Which generally on most editors looks like that. Okay. So, output time. Let's play around again just for a second. What do we get when we cross a chicken with a... No, I'm just kidding. All right. If I say X equals 10, X equals not X. What's X?
Wait.
And then you just said, wait.
X equals 10. X equals 10.
So X equals 10.
It's false? Is it 0?
I think Jen's in the same boat with you. She's like, wait, you're throwing out false? Okay.
0?
So 0. So in this
false is 0, right?
So in this case right here, yeah, because what is true? Because this is a logical operator. This is our toggle. We're toggling true or false bool values, 0 and 1. Which now, as I continue to reduce that down to the C language, 0 or anything. So in this case right here, we could look at it as saying not true, and what is not true is false. But what is a false in C?
0.
That's right. So X actually is going to be a 0 right here. Okay, so very good, guys. Does that make sense how I've got that? Broke my brain for a second. Sorry, Ashley. Exion, good. Jen, does it make sense? Tokyo, absolutely. Good deal. Awesome. Good. Okay.
Marvin has a question.
So, all right, Marvin has a question. Why not anything else than 10? Marvin says X equals 16. What is the result of this?
0.
Same thing. Absolutely, Jonathan and Ashley, same thing. Remember, when we're using this logical operator,
That's a not.
we're dealing with true and false. Okay, that's what these logical operators, that's what they are. Okay, he's got, okay, I get it. But again, back to the whole class, that's what we're dealing with. So now we got to start thinking true and false, and since we're using a not operator, we got to think about toggling. And, well, X has a 16 in it, and 16 is true. So if it's not true, it must be false. But then if we print that out, we're not going to get the word false, because false is what? Is 0.
It's 0.
So that's what we're going to see, okay? So let's go ahead, let's have a little bit more fun. I like having fun like this, because it's cool. What if I said X equals not 0, yeah, times 100 plus 5. Yeah. Rockin', man,
106?
rockin'. Well, what'd you say, Nelson?
I said I know.
Wait,
yeah,
okay,
Nelson.
so then that means 1 times 100.
Code it.
100,
Code it, people. Code it.
105?
Code it. And then put it over in the questions thing. Nelson, do a new participation thing. So that, again, we're logging everybody who's at least put their hands on the keyboards and submitted something. So call this, I don't know.
Hold on, my MacBook's locked up.
No, that's not good.
Oh, there it goes.
Yeah, so call it whatever you want. It's something that makes sense. And Ashley said, you could do that? Yes, you can.
I thought so. Use?
Well, code it out, guys. Oh, Wizzykin says, it seems like you can do anything in Objective-C. I do want to point out, this is C. This is still just regular old-fashioned C, believe it or not.
X equals 0.
Nelson, in the future, when I say name it whatever you want, please, just so that I have good records in the database later, come up with something like expression entry or expression solving or something like that.
Alrighty, sorry, I'm just bad with names.
%D.
Don't worry, Wizzykin. Wizzykin said that I get all of them mixed up a bit. Yep, so do I. So do I.
Uh-oh.
Like trying to assign variables wherever the heck I want.
Do.
So I'm going to give you guys just a few minutes. I'm going to go ahead and pause the video for a second. All right, welcome back from break, ladies and gentlemen. So now let's go ahead and take a look at what I asked for and the code, and let's see if everybody got it or not. So first of all, over on participation, let me just take not participation, view code. We had 1, 2, 3, 4, 5, 6, 7, 8 entries. Come on, guys. Let's get these entries going. You can do it. All right, so here's what I was asking for. So if I jump back over into the whiteboard, this is what I wanted to see. What was this value actually printed out? And I've had 105s and I've had 106s come in, which is really cool that I've actually seen both answers come in. But this is, you've got to do a little bit of thinking here, and Wizzykin is absolutely right over in BuzzNet, and that is what we're seeing here. As a matter of fact, I'll just stay on the whiteboard. Is let's evaluate this. So what is not 0? It's a logical toggle. So 0 is false. So that's right. Jen says 1. Nina says 1. So we're going to say 1 times 100 plus 5. I'm writing on the line there. Now, order of precedence, ladies and gentlemen, all the way back to kindergarten.
Left to right.
Left to right, but multiplication and division comes before addition and subtraction. So what is 1 times 100? Such big, complicated math.
100.
It's 100. So if I was to simplify this entire line now, what we're looking at is x equals 100 plus 5. And for those of you that now said 106, don't feel bad. What is 100 plus 5? Here's your opportunity to redeem yourself. I just heard all of those 106ers scream out 105. You guys are awesome. And that is absolutely correct. And Jonathan said something, I think it was Jonathan just a second ago in BuzzNet, which is a very good point. If we were to jump back over into our code and take a look at what I've done here. So I went ahead and coded it up real quick. And you can see right here that I have done a declaration and an initialization at the same time. The way the declaration takes place is interesting, and we'll see that here in a little bit once we start talking about functions and we start talking about the stack. But X is set up for us by the actual compiler for this function. So it's already declared. Now we need to evaluate what is on the right and then put it back into this area that's already been declared. So what we're really doing is simply taking X and initializing it to 105. Okay. Does that make sense? We're taking X, we're initializing it to 105. Because what I've got highlighted right now is going to be evaluated.
Oh, okay.
And once it gets evaluated, it's evaluated to 105. Now we just have X equals 105. So that's what gets put over into X. X gets initialized to that value. It's really that straightforward. Okay, so if there are any questions that come in with that, let me know, or if that confuses you a little bit. Let's see, Jonathan said, okay, well, it goes behind the laptop. Whatever it is, I will assume that it is, yep, as Sebai just said, basically it's saying that X equals 105. Yeah, that's what we're initializing it with. Let's go ahead and jump over to the whiteboard now. And now the next thing that I want to do is just a couple more real quick exercises. Yeah, let's squeeze some in up here. So what's this going to equal out? And now let's see if you guys can figure it out without coding this out, since you've done a little bit of coding now. If I start out and I say X equals 10, and then we say X equals, all right, thinking caps on, not plus X. So now I'm starting to incorporate things that you have learned throughout the night. So don't forget, when using the incremental operator, both prefix and postfix versions of it, variants of it, that's what I was looking for. So plus X less than equal to 10 plus X plus plus. And not X plus 1. Terminator. Oh yeah, let's get the thinking caps on here. Dementis, if you missed it, it's on the screen. So just take a look at, solve this line by line. Use a piece of paper. And just work your way through it. And Mandrill put 0. So we've got 1, 0. Do we have any other any other values? Anyone else?
I say 42.
So Nelson's got 42. Jen's still working on it. Very cool. I'll go ahead and pause the video, so we'll pause it for just a couple of minutes to give everyone a chance to work through this, and then I'll unpause and we'll talk about it. Pause. Okay, resuming back. I almost got carried away there for just a second and went without bringing the video back in. So a lot of zeros. If this whole expression, if everything was absolutely identical, except for we changed the logical AND operator to ORs, what would we have?
Ooh, I do want to point something out though. Somebody you mentioned, you asked. Oh wow, brain. At some point, there were words, and those words asked if the not was executed before or after the and.
Oh, yeah.
And I did want to quickly point out, I mean, can I quickly describe the difference between a unary and a binary?
Yes, go ahead.
The AND operator, just like the addition operator and the conditional operators and stuff, those are all binary operators because they take in two operands. However, the the increment operator, the decrement operator, and the not operator are all unary operators, meaning they take in one operand. Now, although the not in this case is outside of the parentheses, it's still applied first because it's being applied to a single operand.
Correct.
So that is still technically to the left of the binary operator, the AND. I don't think that explanation came out the way that I intended it to.
No, you said the key thing that when he said that just a second ago, and I said to hang on. The bottom line is yes, it is that not is being that not is being applied to what is evaluated inside those two parentheses.
And that happens before the AND operator
correct.
is being applied.
Does this logic make sense at all?
Let me take a look at Nina's logic here. She's got some scribble on here. Looks all
That's
advanced and
terrible.
stuff.
11. So then that means I figure that was false. 10. I don't know.
So what do we have here, Nelson? Evaluate this. Walk me through. Walk me what to write. Where would you start if you were looking at this?
Let's start with the. Well, first of all, it's kind of like a hierarchy. I would start on the left-hand side of the and first, and then I would jump into the parentheses. Okay. Then I would jump into the left of the less than or equal to. Mm-hmm. And the reason I'm doing that is because of the order of operations. Correct. So I'm going to evaluate that first. I'm going to get an 11. But then I'm also going to put it in the back of my mind that x is now equal to 11.
Right. And
that's important. The next thing I'm going to do is evaluate the expression to the right-hand side of that operator, which is 10 plus x plus plus. Now, because that's a postfix operator, it won't change. It won't evaluate first. So what we have here is 10 plus 11. Then I'm going to simplify the right-hand side, which is 10 plus 11, so that would be 21. And then I would compare, is 11 smaller or equal to 21? That's going to go ahead and evaluate into 0. Wow.
What?
Wait.
Yeah, wow. That was one of the larger fails I've ever done in front of a live class while it's being recorded, and everyone for forever will be able to see and watch this. 1.
Right, because 11 is indeed less than or equal to 21.
Yes.
Now, when writing this out just a minute ago, I do want to point this out. I made sure that. Well, okay, hang on. Never mind. Let's keep on. All right, now, Nelson.
Now I'm outside of the parentheses, so then I would evaluate the unary operator that's being applied to the parentheses.
Yep, and we're getting to
which is the not operator.
Okay, which is
that turns into a 0.
And now something interesting happens, doesn't it, Nelson?
Does it?
Unless I'm getting my languages mixed up.
Well, that doesn't get evaluated next.
No, we have short circuiting in C.
Oh, right.
Yeah, I did this on purpose.
Well, yeah.
And I started to jump ahead, but then I was like, let me, because you were right there at the end of evaluating. This allows me to explain to you guys real quick about short circuiting, which is an optimization thing that the compiler does when your code is being compiled. We know that the AND operator or logical operator requires both sides to be true for the entire expression to be evaluated to true, to a 1. So can't they just say, well, we know if this first side that we just did, Nelson did everything perfect that I was asking for, because that's why I wanted him to walk through his, I was just looking for him to say short circuit, but But he evaluated this exactly how I would, exactly how the compiler would. But then now, because this is going to be compared with the next expression, and the result of both must be true for the result to be true, since this side has already evaluated to a false, we're done. These guys win.
Oh.
So and they call it short-circuiting. There's no reason, because what if this side had all sorts of crazy stuff that had to be done? Wouldn't it be a waste of cycles, CPU cycles, for going in and shifting data into registers and back out of registers and doing mathematical operations if it was something really confusing? If the compiler, I mean, if we already knew that the left-hand side is false, there's no reason to do everything else.
Right, because they both would have to be true.
Yeah, they'd both have to be true. One side we already know for a fact has been evaluated. The left side's been evaluated to false. So it's false, period.
It's funny if anybody out here is thinking that this is a trivial thing to understand. I've seen a lot of bugs pop up where people are invoking functions inside of expressions, and those function invocations don't get invoked due to short-circuiting, and then people get confused as to why their functions aren't being executed.
Exactly. And Mandro just said over in BuzzNet, so if you go like, and then with an if, now you used get assigned. Oh, I see what you're saying. Okay, yeah. If let's say X is already assigned, but then what was said was if X is equal to 0, and then just X equals 0, or no, I'm sorry, X equals 10. Like such. So remember, just all on the same line. Again, even though this is being messed up because you're doing an assignment operation here, it's still a really good thing to demonstrate what I was just talking about a second ago, Mandrill. Awesome is the fact that we're going to short circuit because X is already. And this is, I want to say, and I know you did it on purpose. That's why I was just giving your example. Now let's go ahead and say, though, that X has been initialized to 0, okay? Or actually, no, in this case, because if it is equal to 0, that would actually evaluate to true. So let's say that X is anything other than 0. So then in this particular case, if this side did indeed evaluate to a false, we never even look at this. We exit out. We short circuit and we keep going. And Jonathan said, you can do assignments within an expression. Yes, and they evaluate to the value of what was assigned. Which means if you assigned as...
And you really
you should never, ever, ever, ever do that. That's, as Nelson would say, is dumb. Because if you assign a 0 in...
It's just it's a matter of readability.
Yeah, well, it's just... Xcode won't even allow you to put that in.
Yep.
I'm here, Nelson. Are you not there? Wow, what were we going to say, Nelson?
I was just saying it's a matter of readability to not do assignments inside of expressions.
Right. Now, if Xcode is being slick enough to prevent you from doing that, then that's very cool. That, again, will come down to compiler dependent. But again, that's not how I code, so I've never tried to actually do it. But let's go over here and say, we just start out by saying if X equals 5, print true, and then I'm going, or true, true, and then I'm going to go up and make the statement a little bit more verbose now. So the result of an assignment, but we've got true, and then I have if what we had going on over there was X. What was it that we had back on the whiteboard? What was that Mandro had said again? If X equals 0, and
Y equals 10.
And no, he had and X equals 10. And then now it's actually going to expression is not assignable. And let me see if it's just going to be a... no, it's actually going to prevent that. No, it's Mandro. You didn't break everything. It's still cool. I'm glad that it does not let you.
No, he broke everything.
I'm glad that it does not let you do that here. So let's jump back over here to the whiteboard. Question. Reposting over here, so it'll be seen. Why isn't the less than or equal to on the same priority of execution as the plus, so that you would evaluate left to right? There wasn't another set of parentheses just by definition.
She was because of the way that Nelson broke it down, and why didn't you do the less than or equal to before?
Nelson, you want to join in and wrap up the discussion about the order of operations?
I was actually curious about that myself.
Well, yeah, so you'll notice that in the example, I broke down the left hand of the less than and equal to, then I broke down the right hand side less than equal to. That's because the conditional operators, all the conditional operators have a lower precedence or lower order of operation than arithmetic operators. Arithmetic operators are relatively high in the order of operation list. Unless I just completely misunderstood the question.
No, you explained exactly what I wanted you to say. So, Jen, if that didn't make sense, just holler over there.
So that less than equal to is low man on the totem pole.
Yeah, it's low as far as order of operation. Okay, she said perfect sense. And then I know this is becoming a bit of a jumbled mess, but I said, keep the lines exactly the same. And then what would we get if we had an OR? Well, we've solved the one side, right? We know that this side evaluates to a false, but OR, we're not going to short circuit out here because the other side, if it's a true, we're still going to evaluate to a result of true. So we get to keep going. So now we take a look at X, and we're going to toggle whatever X is, which X has a value, right? It has 11 in it. If we toggle that, because remember the prefix increment operator over here, but if we toggle that value, then it ends up... Go ahead, Nelson.
I just want... Well, no, I'll let you finish this, and I have something to say.
Okay, well, I just wanted to point out that any value other than 0 is true, so if we were to toggle that, now we've got false, so we've got a 0, but we add 1 to it, so we're still left with this side being a 1, so that's true. And then so with using the OR logical operator, the result will end up being a 1 if you were to print this out.
Yeah, just to really quickly say, it doesn't matter what X is. X could be anything, and it'll always be 1. And here's why. Because you're applying the not to it, not is going to return 0 or 1. Either 0 or 1 plus 1 is not 0. So you could easily just evaluate that in your head very quickly without having to actually go through the process.
Yeah, absolutely.
By just noticing that.
Which I don't expect for any of you guys that are truly new to coding to be doing that right now. So again, just kind of the working it out. You'll get better and better with logic and identifying patterns and all as you get more practice in. Practice is so important when coding. You're not just going to read a book or take a class and be an expert at it. Heavens no. Okay, so what I want to do now is we're going to move on to compound expressions now. And to do that, I think I've pretty much utilized every ounce of space. So I'm going to go ahead and bring up our layers and throw myself a new layer in. And let's go ahead and get rid of that. Jump up here. Good night, James. Have a good one, man. So now what we're going to look at is compound expressions. And this is so easy. Whoops. All right. unlike the horrible line. There we go. So now it's an artistic line. So compound expression, just a matter of going in there and having multiple expressions, as you guys saw just a second ago, where I can come in here and say, you know, we're going to say x is equal to 5, and if, and then I say x is greater than 2, and x is less than 8. Then I can say print out basically, so remember, just printing out right here, x is within the range of 2 and 8. So what I've done is like a range check here. So between the range of 2 and 8. So we saw compound expressions just a second ago when we were using them for calculating what the value, the final value that would reside in the variable once the entire line was executed. Now here you're seeing the use of compound expressions in an if statement. So remember, we can do this. Okay, so in this case, and Marvin just asked over in the questions panel, so all of that equals to true. Well, is x greater than 2? Well, x is 5, so yes. So we're not going to short circuit, we're going to keep looking. Is x less than 8? Well, x is 5, it is less than 8, so that's a true, and 2 trues evaluate to a true expression, a true value, which means we're then going to do what is inside of there. Okay, so very, very simple. Now what I'm going to do is, so if there are any questions about compound expressions, let me know. We have already been working with them. And Jen just said, do you have to write code to expressly utilize the short circuit? No, that is just how compilation takes place and how the compiler tries to optimize your code when it's compiled for machine language. So it's all automated, as Jonathan just said. Okay, so the next thing that I want to do is talk about, now we're going to branch out on our ifs a little bit. We've talked about the if statement. Now what I want to do is introduce you guys to the if-else statement. And things are going to start picking up a little bit because needing to know all of these little bitty nuances and different types of operators were all very important, in my opinion, for being able to do more interesting things with the ifs and the loops. So over here to if-else, this is going to blow your mind. Here's the syntax. Ready? If. Expression. Again, syntax. Statement. Else. Statement. Terminator. Dun, 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 dun. That's it. This is going to evaluate if the if statement, if the expression evaluates to a true. This is only going to execute if the expression evaluates to a false. So it's do this or this, depending on the expression. Pretty straightforward. I mean, we saw before that the simple if is we're coming along, we're doing some simple sequential statements, and then all of a sudden we hit this if statement. We're looking at an expression, and if it's true, then we can do this guy here. Otherwise, remember, we were just going to skip over, and then we just continue on, executing all nice and happy. But if it's not true, then we're going to come over here and execute this guy. Notice what that is the most pathetic arrow ever. That is an arrow. So notice how when executing this true path, there is no way for us to get over there. You see it? There's no way to get over there. The line, after we come into true, we do this yes statement here, then we just cruise right on out. We're done with the if statement, and we just continue executing statements that would have executed if the value is true or false. It just doesn't matter. So that is if else. And just to take a really quick look at it, there's no reason to hammer on this one over and over and over. So let's just say if, how about this? So x is 10, and I'm going to say if x is greater than 5, we're going to say x is greater than 5. And then here's what it looks like to bring else in. So now we just say else. And then I'm going to say printf, x is not greater than 5. So right now, if I was to run this, what's going to be printed out? And we can just take this line here out.
I know.
Okay. We all feel more secure now because Nelson knows. Dementis, absolutely, greater, because 10 is greater than 5. So let's go ahead and execute. So build and execute. We see x is greater than 5. And again, this expression evaluates to a true or false. It's true, so we're going to execute the true statement of if. Otherwise, we'll execute this down here if it's false. So let's go ahead and say 3. Or better yet, let's just say 5. It's a good one. So what do we have here? What gets written out to the console? Well, is 5 greater than 5? No, it's equal. Dementis is right. So we go down to the else. We're going to execute this down here. So x is not greater than 5. Let's build and run. So Command R, x is not greater than 5. And Jonathan just said, wow, we are totally not getting this done in 45 minutes. And you are absolutely correct. I knew that these were going to be strenuous classes, but again, I really want to make sure that our beginners get the best education and understanding that they possibly can from these lectures. 4 more hours for part 2. Nah, maybe. So anyways, sick day tomorrow. Oh, goodness. So anyways, that's it for if and else. It's very, very straightforward, very simple. But now I want to expand on what we have seen with both the if statement and the if else statement. So if we were to jump back over now into Photoshop, what I want to do is take a look at compound statements. So compound statements, or what's often referred to as, blocks of code. Everything we've done so far with the if, and now with the if-else statement, everything that gets executed statement-wise based off of the expression evaluation has been one line of code, correct? Everything we've done with if. And if we come back up here and look at even right here, if expression, one line of code, else, one line of code. Let's take a look at what happens if I was to do 2 lines of code without changing anything up with how we're using things now. So if I was to say, well, if x is greater than 5, I want to come in here and say the first printf, and then I want to come into this one and say x is also a cool number. I don't know. I'm it's late and I'm running out of things to say. Well, first of all, the IDE tried to help me out by snapping the line back. But let's pretend you're writing this in Notepad or something. Second, we've introduced a really nasty error here. So we've already see it showing up. And if we were to come over here, take a look at this, expected expression. Well, here we are trying to give this statement here. We've got this else that's he's hanging out. if we don't use anything to denote to this if statement that the code that gets executed, if the if statement evaluates to true, is going to be executing compound statements, multiple statements, then we're going to jack up our program, because this printf is like it tried to do a second ago. See how it backed that back up for me? Because remember, you follow it back up to who printf is not indented to see who owns it. Well, if you look at this like a hierarchy, he's just sitting all the way back up at the root of main.
Oh.
And then else is just sitting out there all by himself. Else is like, what? And the compiler's like, what? If we want to use compound statements, if we want to use multiple statements, Ray Lewis is absolutely right, so is Marvin over in the questions panel, and that is we've got to use curly braces. So if I wanted to do this, and I did not mean to indent that guy, I meant to indent this guy, we've got to do the following. So I need to come in here and block this section of code in. Now, Nelson pointed out last week with functions, this also applies with everything in C in the world of C++. You will see this convention used a lot. Yeah, it's ugly. I agree with you, WizzyKen. That looks hideous. Totally agree. It's just much nicer to look at. But just keep in mind, that's not an error with the way I had it just a second ago, and you will see that quite common in C and C++ programs. I wanted to point that out, but I will be putting my open and closing parentheses like this. For those of you that love to put your opening curly brace on the line of your statement, be it a while or an if or whatever, that's cool with me. I don't have a problem with that. It's preferred to me for readability. It's easier to read. But again, that comes down to personal preference. It is actually this format right here. This is actually a convention that's standard for C# and for other languages as well. But again, either way you guys do it is fine with me. So notice though, the one thing that I want to point out is with using compound statements, I've used the braces around the if portion, but I've not used them around else. Why have I not used them around the else statement here?
Because it's not a compound statement?
Jonathan's right, and so is Nina. It's because for the else, we're only looking at one statement being executed. If you're using only one statement, the braces become optional. This is not an error. And many people code like this, period. I guess it just depends on the mood I'm in when I'm coding along. But this is not an error. The braces are optional if it's a single line. Okay. Any questions about that? Okay. So now we've seen that we can use combinations of blocked code and not blocked code, which is a single statement. And now what I want us to do, wait a minute, we just had a question come in. Do you always keep the return 0 out of the braces? That'll become, that's a loaded question once we start getting into functions.
It depends.
Yeah, it depends. Once we start getting into functions and depending on what your logic is doing. In this particular return 0 is a return from main and should be there returning an integer value back to whoever called this program to begin with. So this return 0 should remain out of all of the curly braces and should reside close to the bottom of the main function. When we start getting into functions here very, very shortly, you will see where returns you can end up with multiple returns. One could be inside an if statement here returning one value. You might have a return down here returning another value. But you get the idea, hopefully. So this return 0, yes. Okay, so examples. I think everybody should be pretty clear on what's happening. This isn't just as long as you remember, if you've got multiple statements that need to be executed for true or false, those blocks of code, those compound statements, must be inside of curly braces, period. One other thing that I want to mention, and then we can jump away from ifs. Well, actually, there's two more, geez. And that is that that kind of lost what I was thinking about for a second. Hang on, talking so much, and this is what ends up happening. Yes, nesting and else if construct. We can also do nested ifs. So let's do a nested if. So let's say that I wanted to say, all right, x is greater than 5, and then maybe here I want to say if x is actually equal to 5, that is the only way that it will be considered a cool number. Again, I can still mix what I've been doing with the combination of both blocked and non-blocked code depending on the number of statements that get executed. But for readability, when we start nesting, I highly recommend to start blocking because, again, it's easier to see. Go ahead, Nelson.
One thing that will bite you hard for example, if you have a compound if, so if you nuked line 12, Jason,
okay,
just really quickly, nuke line 12, nuke line 11, nuke line 14, nuke line 15, nuke line 16.
Wait a minute, line 11, line what, 14?
14.
15, 16.
And,
yep.
Oh, and 15? That too?
No, 16.
Oh, I thought I heard, okay.
No, 17.
17, okay.
Oh, I knew there was another one.
Okay, so now which if is that else paired with?
That's a really good thing to figure out.
Because this will bite you, and it has bitten me, because I will typically, it's a ding.
Yeah, that's great. The warning.
Because it's bitten me where I've used single expression blocks, or not blocks, but just single expressions with conditionals, and then I get mixed up as to where the else's are attached
to. Would it go to the last one?
In the serial,
that else is going to be attached.
It's whatever if is currently the one that's executing. Okay. So the if that's being worked within right now is the inner if of this nested if statement. So it would belong to that one. But like Nelson said, the key thing here is it's very confusing, or can be, or as Jonathan said, sneaky. Sneaky as in what we just did. So let's go ahead and jump back in here real quick. And Chris asked...
The second thing I wanted to say is that's impossible, line 15.
Line 15 is impossible. Let me... Oh, yeah, I see what you're saying. Ha, ha, ha. Let me go ahead and take out... Bear with me 1 second. Okay, and let me add this guy back in too. So here, so this is just an example of a nested if. Okay, so
it's still impossible.
It's still impossible. You don't think 5's a cool number?
But 5 can never be greater than 5.
Oh, you're talking about as far as what can be executed. No, I'm going to change the value of x in a minute. Up top.
Okay.
I see what you're saying. I thought you were just trying to be a smart aleck and be like 5 can never be cool. But yeah, in this particular case here, the only way we can get down to here is if we evaluate to true here and we're inside here. So if I change this over to a 6, this is going to evaluate to a true. Then we'll drop down in here and we're going to say that it's greater than 5. When we hit this line right here, of course, that's false. So where do we go? Well, we don't do this, so we pick up with the next executing piece after we're done with this if statement. Well, what's the next executable piece? Well, remember here, all of this belongs to this if here if it's evaluated to true. So once we're done with this if statement, true or false, if we do it or don't do what's in here, when we're done with it, we then jump down over the else part and just continue on execution. And in this case right here, we're just at line 25. Return 0, and that's the end of the program. So that's a really important thing as those of you that are new to coding start becoming more and more comfortable working with logic. This is another thing that can get people mixed up when you start working with nested loops, nested if statements, etc. Make sure you keep track of where you're at and where you expect to go once something finishes with a block of code. Okay, and Chris asked, is the nesting unlimited? Can you nest inside and then again? And yes, you can. So we can nest. If you end up doing a whole lot of nesting, then you really want to consider rewriting your logic, because you should never go more than 2 or 3 levels deep. Nelson, do you have any specifics on depth from any of the books you've read, like Clean Code, etc.?
In Clean Code, I would try not to even indent as much as you have right here, and certainly not any further.
So you would actually have no nesting whatsoever.
Yeah, I still do, but ideally you shouldn't. However, I do break that rule. I'll at most, if it's code that I care about as far as cleanliness, I'll go at most 2 levels in.
Right.
So what you have right here, but anything further than that, that's an indication that your function is too big to begin with, and things are going to be very difficult to follow. And
I've just always said, as kind of a rule of thumb throughout the years of teaching, I've always said 2 or 3. And 3 is pushing it, and you really need to have a very good reason to be nested that far in. You really should be rethinking your logic at that point. But if you had 4, oh, yes, without a doubt. And again, we come back to people's opinions and the war on the programming holy grounds out there.
Well, except in this case, everybody else's opinion is wrong.
And that's exactly how they all sound as they're fighting out there on the on the holy grounds. Everybody else's opinion is wrong unless you agree. So anyways, I just wanted to demonstrate real quick the nesting, and then one other thing. It would be the if construct, which gives us the ability to do something like, let's say, if x is greater than 5, then do this, else if, and then I'm going to jump down here and say, I'm not done. Hang on. If x is, let me think of something though. And yeah, I know I will move those back. Hang on. If x is greater than 4, then it must be 5. And yeah. Does this actually work like, nope. Can you actually do a, nope. And hang on one second. Goodness. Yeah, I need ReSharper, man. So continuing on, else if x is greater than, say, 2, and then whatever I wanted inside that, and then finally, and I can keep on doing this, and then I can finally say else, and let me clean that up. So in this case, if x is not greater than, or if x is greater than 5, then it's greater than 5. If x is greater than 4, x is 5. Okay? Because if it's greater than 5, it got caught by the first one. Else if x is greater than 2, so in this case, it could be a 3 or a 4. So, and hang on, I was just looking over. Is command square command? Okay, I'll have to try that next. So if I come in here and say, let's just put 3. So x is a 4. And then I can just say, for the final print, so printf x is less than 4. and then x is greater than x is 6. Hang on a second. X is greater than 5. Okay, because x is a 6. Let's change this to a 5. Build and run. So now x is 5. Again, so just the way the if construct works, again, we come through here, check the first one. If it does not evaluate to true, the expression evaluates to a false, we come down here to our else, and then, well, else, and then we just jump in that else into an if, saying if x is greater than 4. And then we're going to do this, else, and so we've got them chained like this so that it's kind of like just a chaining basically all the way down to a final case. So we saw that 5 gave us 5, so let's just keep following it down. So if we do 4, well, x is 4, and if we do 3, now we know x is less than 4, and it is, x is 3 at the moment, okay? So else if. So is there, and Nelson, I'll let you explain this one because I believe you had a really good explanation of this a while back, and if you need help remembering, just let me know. But Ashley asked a question over on the side about, is there a difference between if, else, like such? And yes, there is a difference because this is, well, Nelson, let me go ahead and let you jump in and explain it. See if you remember how you explained it back in the C# days. This is an efficiency thing.
Yeah.
If that helps.
Well, it's efficiency thing. It's a few other things. For example, if Jason had x equal to 6 and took off all those else's, except for the last one, then 3 things will print.
Okay. Keep going. Well, I was just looking for, as opposed to doing if x is greater than 5, and then we don't use the else if construct. Let's say then we just go to another if statement. You're going to end up if x was, let's say if x was greater than 5. So this, now remember, just pretend that all of these else's do not exist, okay? So if x is greater than 5, we're stipulating at 6. Okay, so we're going to print out x is greater than 5. If the x did not exist here and it was just a whole bunch of ifs, then what's going to happen on line 14 is even though we already know x is greater than 5, it's still going to check. Is x greater than 4? No, it's not. All right, well, let's come down here, line 18. Is x greater than? No, it's not. It's going to come down here. It's going to do all of these comparisons and all of these ifs all the way down. And this, using the if-else-if construct, allows us to streamline it in such a way that the moment we finally found the expression that evaluates to true, we don't check any more of those else ifs in there. We're done. So again, let's stipulate x is 6. So if 6 is greater than 5, yes it is. All right, print this. What's the next line that's going to be executed after line 12? What's the next line? Just give me a line number, anyone. Come on, 3, fast, fee, ha, he, ha, hoo, ha, and. That's right, Jonathan. Line 29, return 0. Very good, Mr. Lewis. Absolutely, because we're not going to come and do all of these other checks. They're all chained in through all of these else's. Okay? So that actually, very nice, Exion, that actually makes a big difference, a performance difference, especially if you're trying to be efficient with your code. There's just no reason to check all of these other guys. So in a situation like this where you're comparing something numerous times, then you may want to take a look at using the else if or the switch statement, which is something we can look at a little bit later on. Again, timing wise is the only reason I toss that one out for tonight. So not to mention that this is also pretty straightforward and easy to see too, in my opinion. Though don't go crazy with it, all right? And put 9,000 of these in place. So there is a look at all of our different selective flow control constructs with if and else if, and then the if else if construct, and then there's the switch, and the switch is something that we can take a look at later. So from here, what I want to do is move into looping. So let's go ahead and jump back over into here. And let me go ahead and bring up, as I strain to see the keyboard. So let's bring this guy up. Come up here. So time for some more fun. So we're going to take a look at iterative. Flow control. Wow, I just looked over at the list of people in class, and I remember saying goodnight to James earlier, and he is the only person we have lost. You guys are amazing. You guys really are. Iterative flow control. Referred to as looping. Are we still really in part 1 of week 2? Oh my God. Yes, ma'am, we are, Jen. I'm sorry. I could go a lot faster. I just don't want to jeopardize anyone who's picking this stuff up, or this is helping really solidify what they may have seen in the past. Okay, so with the iterative flow control, the statements that we're going to be looking at will be the while. That is an I. Loop. We'll be taking a look at the ever so popular do while loop. And how could we possibly move on without taking a look at the for loop? Yeah. So, looping. Why do we need it? Well, I gave you a very basic example earlier. If you guys recall, we were talking about a classroom full of students and needing to go through all of the students and perform some sort of operation, the same operation on all of the students. We don't want to have to rewrite the code over and over, and if those number of students vary between different executions of our program, then we've really got serious trouble. So, if we're coming along and then we've got code that's going to be repetitive, so statement, we did another statement, and then all of a sudden we hit this area where it's like, man, I got these couple of statements that I need them to repeat and to repeat over and over. And I want them to just keep doing their thing until I'm finally done with repeating and then exit out and continue. That's iterative flow control. That's looping. So we're looping over code. So taking a very quick look over at BuzzNet, because I saw a couple of things said. I almost never see the do while. I wonder why. Okay, we'll talk about that here in just a moment. And making sure there are no questions. And okay, we look good all over the place. Fantastic. So once we start getting into looping, so the first one's going to be the while loop. I'm going to start drawing out our boxes just a little bit differently for how they look. First of all, let's look at, so remember, we're focusing to begin with on the while loop. It can't get much easier than this. This is what the basic syntax looks like. While, so the while keyword, and then expression. See, aren't you guys happy now that I taught you all of those cool operators earlier that we can use to manipulate expressions? And then inside our while loop, you'll notice I'm going to indent over statement. I do want to point out to everyone that what we talked about with the if statements, as far as compound statements go, applies exactly the same to our while loops, our do while loops, and our for loops. In this very basic syntax right here, how many statements are we showing that we are executing? 1. Because we have only 1, we do not need an open and a closing curly brace. So if I wanted to do multiple statements, then we've got compound statement execution. I need an open and curly brace. Okay? So this is important to understand. So the way the while loop works is as long as our expression evaluates to true, we're going to do what is inside of the loop. And it's kind of what I like to refer to this with all of the loops. The code that gets executed if the expression is true, that's the code that's inside the loop. All right, so let's go ahead and undo my craziness there. And let's take a look at a written example first. So if I come in here and say int I equals 0, we all know very well what that does for us now. And then if I say while I, now we're going to start using some of these comparison operators from earlier. If I is, no, let me not say that. Let me say if I is just simply less than 3. Then I'm going to come in here and I'm going to, again, pseudocode. I'm just going to print out I equals %d, and we'll pretend there's a new line there. So first thing I want to do is just this. What is going to happen when I execute this program? I have purposefully made an interesting scenario. Awesome job, Mandrill. Go ahead, Nina.
Because it's false?
Move your mic back over. I can hear you. Because it's false?
It's false? Because
I is 0.
Right.
Is 0 less than 3?
Well, it's less than 3, so
That's true.
that's true.
So if it's not false, it is true.
Right. Okay. I is less, yeah.
So this right here evaluates to true.
Oh.
And remember what I said. If it's true, we
that's
execute
gonna happen.
the code in the loop. So we come in here, we execute this line. So let's pretend here's my console. You guys like my console, don't you? You know you do. I equals, so what is I currently equal to?
0.
0. And remember, I said let's stipulate there is a
My
new.
brain went to false because it's the 0 there. That's why I said
Gotcha.
false.
So
Sorry.
let's just stipulate that there is there's a line return there, or new line. Okay. So now, where are we at? We're at what I like to refer to as the end of the loop. So what happens at the end of the loop? Well, check it out. Here's the looping. We come back up, and we look at our expression again to see if we're going to do the loop again. So is I less than 0? Or, I'm sorry, is I less than 3?
Yes.
Yes. So she answered yes. What does that mean? Do the loop.
Yep.
So we're now inside the loop. I equals, and what is I? Well, we just said 0, and I'm stipulating there's a new line. Where are we at? For those of you sitting at home, say it out loud. Into the loop.
Into the loop again.
What happens when we get to the end of the loop? We come back up, and we recheck our expression. What's I? It's 0.
It's 0. It's less than 3.
So, what we're going to do the loop? Yes, because it's true. The expression is true. So, we print out I equals 0. Do we see the pattern here?
It's going and going and going and going.
So, Marvin, you're absolutely right. It's an infinite loop, and several of you also got it over there in BuzzNet as well. And those of you that also said, that I equals 0, and you're going to see that over and over and over forever, yes. This is what is referred to as an infinite loop. There are times that infinite loops are useful, and you have to have other ways of breaking out of them instead of relying on an expression. These are things that we will be talking about more as the course progresses. But right now, for us to come in here and fix this, all right, Saturn. If you want to, then we go over here and put I. Remember, I'm just stipulating that all that stuff's there. I don't want to have to keep writing it all out. Marvin, same goes for you. Format specifier, yes. Also, it doesn't need to be a P. It needs to be printf. So we all know how that works. So we're stipulating, okay? We're just going with the flow, people. Come on. Okay, so to make this loop work, what do we need to do? All right, Xeon official said initialize. Well, we do initialize. This line right here is a declaration and initialization. Dementis. How to fix the infinite loop? Simple. I++. So what I'm going to do, I'm going to come in and on the next line, I'm going to say I++. Terminator. And we can say ++I, we can say I++, doesn't matter. So now what happens? Let's reevaluate my little sexy mess here. We come in, I gets currently set to a 0. So now I want to track what's in I. So currently, I is holding a 0, right?
Yes.
And here's our awesome console. So we come down, execution is right here. We're inside the while. The very first thing we do before we get into the loop is we check to see if our expression is true. Doesn't that mean there's a possibility that I might not even execute the code inside the loop?
Yes.
Absolutely. What if I say int I equals 5,000?
Then it's false.
It's false. So since the expression evaluates to false, we don't even do what's in the loop. We just jump right over. But in this case, we've got I is set over to a 0. So we come down here and we say, is I less than 0? Well, yeah, 0 is less than 3. We're all good with that. So we now jump down inside and we're going to do a print and we're going to say I equals, and then what is currently in I? Well,
0.
It's a 0. So we get that printed out. Sweet. All right, so then what do? We now, execution goes to the next line. Remember, we are using compound statements, so we have these guys blocked in properly. So now, I++. All right, well, we're going to take what's currently in I, and we're going to add 1 to it. Sweet. So what does I become?
1.
Absolutely, it becomes a 1. Now, out loud, where are we at, ladies and gentlemen?
That's the end of the loop.
We're at the end of the loop. What happens when we're at the end of the loop?
Go back to the beginning.
We come all the way back up here, and we got to run our test again. So now let's go ahead and do the expression. So now, check it out. Our expression's actually changing. Is I less than 3? So is 1 less than 3?
Yes.
Yes, it is. So now we're going to come down and do the loop. So again, we're printing out I equals, and what's in I?
1.
A 1. Come down, we now execute the next line of code. What is going to happen to I?
2.
It gets incremented by 1. It now contains this ultra sexy 2. So now, where are we at?
The end of the loop.
End of the loop. So where do we go?
Back
up to the top. So now we can say, is 2 less than 3?
Yes.
Yes. As long as the expression evaluates to a true, which is any value other than 0, we're going to do the loop. So the answer is yes. So we're going to fall down inside the loop again, and we're going to print out what is in I. So I equals 2. Now we execute linear execution. Next line. So what happens to I? I++.
3.
It's incremented to a 3. All right, so we now have a 3 in I. Where are we at?
End of the loop.
End of the loop. So we jump back up here to the top again.
Boom.
Is 3 less than 3?
Nope.
No. It's false. Anytime we say false, we're done with the loop. We just simply exit out of the loop and continue execution after the loop itself. So whatever statements come next. So does this make sense?
Yes.
Very straightforward. What I want for you guys to do, real quick, Nelson, go ahead and clear and add a new record for send code, and call this call it while loop example. And what I want you guys to do is code the example. And I will go ahead and pause video. So code it and then send code. Let me see who can get code to me. I want to log this stuff. And we'll go ahead and pause the video. Resume. All right, welcome back, ladies and gentlemen. Yeah, all right. It's late. I can't even talk straight. Welcome back, ladies and gentlemen. It's time to get things going once again as we continue where we left off. At this point, everyone should have put together a while loop example. One was given on the whiteboard and submitted it through BuzzNet. Now, if I just happen to move my cursor over here onto a whole different computer, I am quite impressed to say, now I know you guys cannot see this at the moment, but it's on my PC, and right now I'm broadcasting from the Mac. But I can see that we've had a lot more entries this time. Fantastic. So just a real quick look through. Some people having a little bit of fun. Wait a minute. What was that one? I saw a note in there. Fix the terminator. Okay, good. Good deal. Thank you guys for the submissions. Greatly appreciate it. Very cool, Mr. Wizzykin. So let me go ahead and jump back over here. So some really simple challenges, really fast. So output of. So we just did, well, let's just, give me the output of what this is going to be. So if I said x equals, I'm going to switch to I now. And this is, the only reason I'm doing this is because with loops, it's just pretty common for me to use I and J and K for variables that are used for, temp variables in counter type situations in loops. So let's say I starts out equal to 0. And we're just going to stipulate as an index. Yeah, and as Nelson just pointed out over there, I for index. So now I'm going to say while I plus plus is less than 3. And then we're going to say print. And again, lots of stipulation on what we're typing here. I equals %d. And we'll do pretend there's a new line there. And then also that we have put in I here. So what is this going to give us? What's the output?
Okay.
I'm also going to write it again. So I equals 0. And do we have the same output if I now come in here and say while I, and let's do this now. Let's say plus I, again, I'm just driving home concepts, is less than 3. Same thing. Print out I equals, and whatever's in I. So what do we end up with here? So two things that look almost exactly the same. As a matter of fact, I'll go ahead and scooch this up just a little bit and do this. So while you guys are So same thing. We're just going to say print out I and whatever it is. Terminate. And then I'm gonna come in here and say I plus terminate. And there we go. So there's three cute little examples. And what do we get from those? So we have all sorts of fun things that are being said right now. Wow. So let's see. So for the first one, what do you guys say for the first one? Sorry, so I'm seeing and I won't do the I, well, yeah. So I'm seeing I equals 1, I equals 2, and I equals 3. You guys are all agreeing on that? You guys are all together? Okay, Jonathan's like, yes. Jen's like, no. Everyone else, shut up. This is how it's going to be. Jen, what do you think it is? She's formulating her plan. All right, so Jen thinks it is I equals 0, 1, and 2. Okay, very cool. All right, good. So we'll come back to this one in a second.
Yeah.
Now let's go ahead and take a look at the next one. So for example 2, give me, what do you guys think it's going to be? All right, so Mr. MMO Dust says we're going to get I equals 1 and I equals 2. And Jen is in agreement with that, and so is Mr. Wizzykin. Jonathan has dozed off. His answer was ha. That does not count, sir. Okay, so, all right, so 1 and 2, and Nexion Official has given his standard 42. Fantastic. All right, so now let's move down to the next one. What is the last one going to be? So for the final one, MMO Dust is giving me an I equals 0, I equals 1, and I equals 2. And I saw somebody laugh. Hang on, let's see. Now I doubt my first answer from Jen. Okay, her 0, 1, 2. So this is in question. Fair enough. And then Mr. Wizzykin said, it's a regular loop for the most part. So he's also going, so everybody, Jonathan, what do you think for this last one? So Mr. Wizzykin's also saying, the standard 0, 1, and 2. And Jonathan agrees with him. So the standard stuff. And so does Dementis. And I am shocked. Absolutely shocked. Wow. Let's go ahead and jump over and take a look at at some of these results, because for the most part, they're really good, but not all. Pretty much everybody did fail one of them for sure, including Jonathan, which is shocking. So let's just, I'm just going to kill out all of this, and let's start out with int I. Whoa, already way out there. Int I equals 0. And then, let's see, where did I throw my basic challenges? There we go. So we're going to say while, actually, let me keep it looking the same. While, and then for the condition here, we said I++ is less than 3. Then we came in here and we said to print I equals and %d and a new line, and then let's go ahead and give it I and terminate. Everybody down with that?
Yes.
Sweet, good. Let's go ahead and run, and we get 1, 2, and 3. And that is correct. Okay, so, and again, the remember that I++, remember how it operates. Even though I starts out as a 0 on line 8, it's the way it's initialized. Then when we drop down on line 9, we first test our condition with I, with whatever it currently contains. Is it less than 3? We have a post incrementer here, so a postfix, which means after this is evaluated to a true or false, we then increment I. Okay? So now we see how that works. So 1, 2, and 3, good job. So now let's come down here and say int I equals, and then let's go ahead and, I'm just kidding. I seen who all was paying attention. I equals, I'm testing to see if you were still awake. So I'm resetting I back to 0, and then I'm going to say while, and now let's just go ahead and do prefix I is less than 3. And then I'm just going to steal the same line. Paste it down here. And then let's go ahead and run. And I can go ahead and just give us an extra printf, and we just do a couple backslashes there just to make it a little bit easier to see. Okay, so 1 and 2. All right. So now, very nice. Let's go ahead and move on to the next one, which I had said was going to be again, I is going to be equal to 0 to reset our counter. And apologies, let me go ahead and copy this just to, again, for, whoa, no. Pasting. And good, look, done. Hang on. Let me grab my mouse, not my fingers.
Paste
yeah,
harder.
exactly. So again, let's go ahead and
Paste harder.
Ooh,
what did I lose? I didn't hear you.
Oh, I said that like 5 seconds ago.
You said what 5 seconds ago? You said what? Nelson?
Paste harder.
Really?
Oh. Wow. Oh, okay. Yeah, you were suffering lag with you. So now.
There's a huge delay because I can hear you in the other room, and then like it comes in like 5 seconds later.
Okay, so for the last condition, we're going to say while, and then what did we do for this one? It was going to be I is less than 3. Yeah, we incremented over in the thing, so let's move that down. And then we had same line. I don't remember if that was the last thing on the clipboard or not. So we'll paste, and let's just jump over here and say we need to do I++. And run. And this is what we get. Yep. So while loop has empty body. Now, I saw just a second ago where somebody said that I was going to be... MMO Dust says, I'm thinking Jason might be surprised. This is what I was expecting. What? He hit it on the whiteboard. What? That's not hidden. That is not hidden, ladies and gentlemen. That is right there. And that is something that, especially for beginners, will bite you in the butt. And then finding that, oh man, if you have a big program, it really can burn you. I've seen students in the past get burned by that. So fortunately, our IDE is smart enough to go, haha, we have an empty loop. But do be careful, especially if we happen to start throwing tests your way very soon. To test knowledge, where it's not just everybody throwing out their thoughts over in Syncode. I had Nelson dust off the old testing system yesterday and today. So I just wanted to make sure that you guys start paying close attention to the actual code when I'm doing small code snippets like this, looking for output. Putting the terminator at the end of a while like this, that's it. It brings it to an end. That's the end of the loop. Same thing like with an if statement. If after the if expression I put a terminator after that closing parentheses, we're going to run into the exact same problem. That's the end of the if. Okay? So Jason's out to catch us. Jen. All right. Good job, guys. So cruising down through, everybody was looking fantastic for the first one. Jen, you see what happened with the second one, right? And you understand why it is the way it is because of the that incremental operator. And then, so I'll give you a second to hear that because you're okay. Good. And then everyone was cruising along beautifully with this one, and then everyone bit the big one on this one. So why does it allow empty braces if there's a use for them? Empty braces are interesting, Wizzykin. They're a way to block code. And this is stuff that we can talk about more later. I don't want to get off too much on a tangent, but we can block code and variables that we defined inside of curly braces have a protected scope from things that are outside of the curly braces if those braces don't belong to like an if statement or a for loop, etc. So it's a way to create variables that are then going to be destroyed, not accessed externally. So anyways, but that's enough on that because that's getting off a little bit too far. So anyways, there is a quick look at some of those fun little examples. The next thing I want to do is to take a look at the do while loop. So very, very simple here, fortunately. And that is, so let's go ahead and write, that was the top, wasn't it? Hang on. No. Mm-hmm. Sorry. There's the top. I need every bit of real estate space I can get. Okay, so do while. We have one problem with our while loop. What is it? There's only one problem with the while loop that we looked at.
What is it? I keep going and going and going?
Nope.
Oh.
Just while loops in general. We don't have a guarantee that the statements inside that loop will be executed even once.
Oh, okay.
We saw as we worked our way through the while loop, this is kind of this is our limitation on the while if you want to look at it this way. Let's say that what is sitting inside this expression is something as a programmer, we don't know what it's going to be ahead of time. And whatever it is given, let's say that it is something that may cause the code to not even execute. Let's say that the very first time we hit this while loop, the expression inside here evaluates to a false, and we just jump right out. Okay?
Oh, Marvin's leaving.
So, and, okay, Mr. Wizzykin is heading out,
Yeah,
and
Marvin.
you have a good one, sir. So anyways, so continuing on, what if the code inside this while statement had to be executed at least once?
Then you'd be in trouble with
We'd
the
be
while
in trouble.
loop.
And that is what we get with the do while statement. So let's go ahead and jump back up here and take a look real quick at syntax. What a hardcore night. Even Marvin hanging in all the way up until just now. I'm so impressed. I'm impressed with every single one of you that are still here. It just blows my mind. You guys are awesome. You guys make me want to just keep doing this all night long. Okay, so in syntax here, so let's take a look. It goes like this. Keyword, do, statement, terminator, while, expression. You wait for it. Here it comes. Here it goes. Here it comes. Here it comes. Terminator. All right.
Do statement while.
So the same exact thing applies that we've already seen in regards to if the need to execute compound statements exist, we just simply need to make sure that they exist within our open and closing curly braces, that they're blocked, okay? So for a single statement, as we're showing here in the basic syntax, these guys are optional. Yay!
Yay!
So simple. I'm not going to beat you guys to death over this one here. But what is important with this one is coming in here, our statement will execute for sure at least once.
One time, okay.
So we're going to come in, we'll execute the statement or statements, then we'll come down to the expression, we'll evaluate the expression, and if the expression is true, we will come back up and we'll do the statements again. So now we're checking at the end instead of before each iteration. So a very quick example is if I wanted to, let's just do this example to save a little bit of time over here on, because again, we're getting into stuff that's very similar now. And that is, so I've got I is 0, so let's do, and man, let me make that look a little bit prettier.
Boop.
All right, so statement. So let's just come in here and say I'm going to do a printf, and I'm going to say I equals, and then %d, \n, the typical stuff, comma, and I, and terminate. And then for my condition, I'm going to say while I is, I don't know, what should we put in here? While I is less than 3. Let's keep doing it. Let's just use what we've done before. Now, same problem here. I need to do something with I so that I is actually changing. So if I want to, I can go ahead and jump out here to the end and just do another I++. So as Jen said, let's just increment it like so. And now if I was to run this, so let's go ahead and build and run. Oh, we're still running a current program. How fun. So let's go ahead and stop. We run it. And we can see that what we've got is a 0, 1, and 2. Okay? Miss a semi? Smack. Oh, you're talking to me, Nelson? Okay, so continuing on. So just right here, there is an example of that. Now let's watch this. What if coming into the actual loop was a variable with a value that was going to not evaluate true? So let's just do 5. Bless you.
Thank you.
So i's now set to 5. So if we were in a regular while statement, we're going to evaluate to false right off the bat, and we're not going to execute any code. But with the do while statement, we're guaranteed the code being executed at least once. So let's go ahead and run. And again, there you go, at least once. Does that make sense to everyone? So that's the big difference.
Yes.
I'm looking around the room. It's awfully quiet.
Yeah, I understand.
Okay, so Nelson's good. Seaby's still with me. Awesome. Jen asks, spacing on the last curly brace.
This is a.
Go ahead, Nelson.
I
I'll
hate
let
it.
you, since you're so passionate about all this stuff. Go ahead.
Well, I like it the way it is, but I don't like it the way it is. Does that make sense? I like it the way it is more than I would like the alternative, but I still think it looks ugly, especially when the while starts to compete with the last line of the block, and it just sets my OCD off. But then if you break it off into a line, then it looks like it's another while, and then the world just
That's the big
ends.
reason why I don't like it off on another line. To me, when quickly scanning over code, it looks like another while. So I personally like putting it at the end of the do's curly brace block. So this is kind of the common convention with most C programs with most do whiles I see. Let me put it that way. So very straightforward, very easy. The key thing to understand is that we guarantee the execution of what's within the code at least once. That's the important thing here. We don't have that execution otherwise. And then also, we have this terminator on the end. You can see that without the terminator, that we cannot build. It is a required thing. So that is the do while statement. But what I'm getting at is that's the do while loop. So there's one more loop that I want us to look at, and that is the for loop. And for loop is going to give us a bit more control over things. So with the for loop, here is the syntax. So the syntax is simply the keyword for, open parentheses, and I'll just write EXP, expression 1, terminator, this is critically important here, expression 2, terminator, expression 3. In parentheses, statement. And terminator. This is our for loop, basic syntax. These guys right here are all optional. So what do we generally find in those guys? Generally, this is an initializer. This is going to be your test expression, if you will, to see if we're going to continue doing the loop. And this is generally your incrementer or decrementer. So let's see what this would actually look like then with some code. I could come in here and say for int I equals 0. Terminator. What this means right now, notice how I'm declaring this int I inside of this first expression on the if statement. that makes this int I something that's available only for the for here. After we're done with the loop, we're done with this I. It doesn't exist. That's a scope thing. We'll be dealing more and more and more with scope a little bit later. So now for our test, or as Jonathan said, condition. So now, just like we saw with the while loop and the do while loop, now we need some sort of expression that we're going to use to determine if we're going to do the contents of the loop or break out. So in this case, I could say, you know, as long as I is less than 3, since we've been doing that one a lot. Terminator. Again, very simple expression. And now for the third expression, this is the incrementer or decrementer. In this case, I'm just going to say I++. Terminate. And then if we're going to do compound statements, make sure you put them between braces. And then if I was to come in here and just say print out whatever I is, I'm really doing some pseudocode now. So again, all the standard stuff, but I'm just printing out whatever I is. The way this works is as execution's coming along and we drop down into here, the first thing that happens is this for gets a variable created. So its own little sublocal variable, if you will. It gets initialized to 0, just generally why this is called the initializer here. After we do this, we come straight over here and we check to see, are we going to do the loop or not? So we do the test. Is 0 less than 3? And the answer is yes. So that means we do the loop. So notice I didn't touch this at all. Okay? Didn't even mess with that. That actually happens last. So we come down in here and remember here's our really cool console over here. So now we're going to say, we're just going to print out I. So I'm going to print out whatever's in I, which is a 0. So execution then goes to the next executable statement, or if there's not an executable statement, where are we at? What do I like my beginners to say when we're learning loops? Where are we at? Nina, where are we at?
Back to the...
We're at the end of the loop.
I mean, at the end of the loop, yeah.
Okay, end of the loop. Good, Jen. Very good. So we're at the end of the loop. So in this case, watch what happens here. We now visit our incrementer. 0 becomes a 1. It gets incremented by 1.
Okay.
Then we retest. So is 1 less than 3? The answer is yes. So we now do everything that's inside the loop. Here it's just one line. But so we're just going to print out. So in this case, what's in an I? A 1. We execute the next executable statement. In this case, there are no more. So we're at the end of the loop. So what do? We come all the way back up and we hit the incrementer. Again, 1 becomes a 2. We check the test. Is 2 less than 3? Yeah, last time I checked, sure is. So we're going to do the loop, which prints out a 2. So again, we came down. We did all of the statements in our compound statements here, but it's just 1. Nothing else to execute. We're at the end of the loop. Again, we jump back up again. We hit the incrementer. 2 gets incremented to a 3. That is a 3, ladies and gentlemen. So we come over here. Is 3 less than 3?
No.
No. It is equal to 3. So watch what happens. We're done with the for. We jump over our for loop and we continue executing statements that are now outside of the loop. You can write while statements and for statements and have them look exactly the same. I mean function exactly the same. And Nelson, to give myself 2 seconds worth of break here, you want to jump in and talk about selection of for and while and why you might want to use one over the other?
It's like my decided to get tangled in my hair. Yeah, I mean, for loops are convenient whenever especially when you're using some sort of value that increments by some sort of fixed value. So that's a very, 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 very common use case for loops. where you have a counter like an I variable. You start off at some number, and then you go to another number by some set increment. That's one of the most common types of looping in any programming language you might ever encounter. Because of that, the for loop is just a nice, succinct, easy to recognize way of expressing that code. And especially by saying easy to recognize, become familiar with the for loop because everybody else uses it. And if you want to express the idea of iterating over a range of values, using the for loop will make your code a lot more readable to other people because they'll have a general idea about what you're doing.
Very good. So that was a good answer. If anyone has any other questions in regards to that, the more you work with loops, you're going to find yourself, preferring, like, it depends on what I'm doing. Like if I'm doing a game loop, I'm going to do a while that's like while true, and I'm just going to let it run forever until a user ends up bringing up a menu and selects exit, and then I'll break out of that loop, which we'll show you how to break out of in just a moment. If I'm working with numbers, like in this case here, I'll find myself using a for loop almost always. And like Ashley had said earlier, do whiles they're just used so much less frequently. I don't use them as often. Okay, so anyways, that's what we've got going on here now. Nina took it upon herself to because she's following along, doing an awesome job, and she was typing this over here and came up with a very interesting scenario. And I just want to, just so that we've seen this, let's go ahead and
my error.
Let's go ahead and take a look at what Nina had. So just so that the code's actually typed out.
I did break it for a moment.
You're not allowed.
So look at look at the help that I'm getting here from the IDE: initialization, condition, and increment. So let's go ahead and jump over, and for initializer, let's say int I equals 0. For our condition, I'm going to say if I is less than, and still these are still just expressions. I is less than 3, and we're going to do I plus plus, and then I want it to look like that. It looks nicer, and now I'm going to come down here and I'm going to say, let's go ahead and print out I equals %d \n I, and there we go. Okay, so if we come in here, build and run, we get 0, 1, 2, just like we drew out a minute ago. But be careful. Nina had done that.
Oopsie.
And was like, what's going on here? This is an interesting one, because if we take a look at our error, we got use of an undeclared identifier. I. Very interesting. Think about it. Even more interesting would have been if I did this. Int I equals, well, let's just say int I. Now I'm going to come down here and say I equals 0. So it's using the global one. So now, take a look at this. So I haven't initialized it here. I'm relying on my for statement to initialize it. That's horrible, for the record. But now, int I can be seen all throughout the main function. That's important to understand. It can be seen all throughout the main function. So remember, it's an identifier. I is just an identifier. But we saw a second ago that if I did this, and remember when I was writing this out on the whiteboard, I had said that that I only exists inside this loop. Once we're done with this for statement, I no longer exists out here. It's gone. So in this case right here, since this terminator is ending the for statement, we're done. Terminator's over. It's just an empty loop. This is fine. This is just a blocked piece of code. But I'm saying to use I. There is no I here.
Right.
So that's why we're getting the error that we are currently seeing. So I just wanted to point that out, because when she typed it in over on the side, I looked at it, I was like, oh, that's weird. You might want to consider taking off the terminator right here so that it all works right. And of course, once she did, it was happy and everything Worked well.
Wasn't broken anymore.
Okay. So, simple for loop. So what I want for everyone to do real quick is to write me a for loop that counts from 0 to 100. I want it to print out 0 to 100, but I want you to count by, I don't know, what do you think, Nelson? 5? So it's not quite as much. 10? How about count by 10? Increment, steps by 10.
Yeah, or 13, because that's an odder number.
All right, because I'm trying to keep Nelson awake here. So here's what I want you to do. I want you guys to write a for statement that will, when you execute it, what its printf is going to do is it's going to print out the sequence, but taking steps by 13. You're going to be stepping by 13. Nelson, get in here and talk a little. I'm trying to keep you awake, man.
Oh my goodness.
Words and stuff. Yeah. Hi, Nelson. How's it going? So here, you give them a description. Get same description.
Write a program that outputs numbers with up to 100 in increments of 13. Or how about up to 500?
Up to 500. Oh, okay.
Well, 13.
I know.
There's less than.
Well, the only reason I was doing that is I was keeping the output kind of reduced on the screen, but that's cool. So let's go ahead and pause. I was going to say mute the video recording. No, let's pause the video recording and give everybody a minute to whip this out. Resume. All right, welcome back, ladies and gentlemen. What we're going to do is jump over to Nelson's screen real quick. Let him type just to help him kind of stay with the flow tonight. So we're going to make you a presenter, sir. It's a very easy program, but this is where, if you're new to logic, this could be difficult because you got to think about how you want this, how this works.
Increment, decrement.
So as you can see, Nelson is putting in a comment saying to print numbers from...
For everybody else's benefit, not for me.
Gotcha. Come on, Nelson. Try to find a little bit of energy. You can do it.
I did that.
All right, so what I have here is the code that goes ahead and prints out. That kind of bugs me.
What Nelson didn't like was that comma at the very end was driving him nuts after the 494.
Yeah, I need to get rid of that. Okay, so what we have here is a for loop that has the 3 different components: the initialization, the comparison, and the action. I believe it's... Did you call it the action before,
No.
Jason?
No,
Because I've always heard it referred to as the action. What did you refer to it as?
incrementer in this case.
Okay, so the incrementer, or the action, or technically any code.
It's an expression, I mean.
So we start off at 0 by initializing our counter variable, in this case named I, to 0. We then specify that the condition to continue this loop is that our iterator, or index variable, is smaller than the integer literal 500. So as long as this expression is true, the for loop will continue to execute. Then in our action, we specify that upon the end of every iteration of this loop, but before the condition is tested, we want to add 13 to our iterator value. Then we go ahead and print out the iterator value on every iteration. And I did add this, which adds a comma for every item that isn't the first item, which makes the output not
comma 0. Yeah. So, if you took a different approach to doing this, that's cool. I mean, the thing here is just notice that when it's time for us, after we pass through one of the iterations, or each of the iterations of the loop, and we return back up to our incrementer, we're incrementing by 13. That's instead of stepping by 1, we're stepping by 13. We're incrementing by 13. In the example that I gave before, I did just by 1. As a matter of fact, Nelson, go ahead and just change that 13, change it to a 2. And watch this. So now if he does that, now look at all these even numbers. So we start at 0, then we got 2, 4, 6, 8, 10, 12, 14, so on and so forth. Okay, so does the logic here make sense? Does it make sense? Why? Don't worry about lines 10 and 11. That's just Nelson getting fancy.
Well, I wasn't looking for 500 numbers. I was looking for the numbers in between. If I do the I is smaller or equal to 500, will that include the 500? Yes. So in this particular case, this will proc. As you see down here, there's a 500.
Okay, so I'm going to go ahead. Thank you, Nelson. And that didn't work out as well as I was hoping. That it would charge Nelson a little bit, but I'm going to go ahead and jump back over to me.
No, that was full of energy.
Wild man.
Yeah, I'm telling you, I just don't know how to handle it. So the final thing that I want to mention with our loops, I want to mention the break and the continue keyword. Because there are times where, like I had mentioned earlier, you may want to have an infinite loop, where an infinite loop can actually be useful. Nelson, talk about the usefulness of an infinite loop. Why would we ever want to do such a thing? Jeez, it sounds horrible.
Well, there are a few different instances. One instance that comes to mind readily is when asking a user for input. So in this case, I could do something like while true, and for some reason, and C.
And remember, we're not looking at your screen anymore either. But you could say,
oh, well.
But go ahead, keep talking.
That one, yeah, I didn't know. Which you just pulled the rug from underneath my feet.
Okay, I actually said I was switching back to my screen. Here you go. There you go.
Just completely. So yeah, a while loop, like collecting user in, you might want to continuously loop. Oh, you switched.
Yeah, I gave you control back.
Okay. I was just going to really quickly just show something like, collect user input. If user input is valid, then get out of the loop. If not, continue.
As a matter of fact,
like this would be
I will let you go ahead and just take them through continue and break. Since you're right here at doing the infinite loop, it's a good place to use anyways.
Yeah, so in this particular example, I want the user to enter a number between 5 and 10. So what I'm going to do is, first of all, I'm going to collect the user input. I'm going to say printf, enter a number between 5 and 10, and then I can do scanf and go ahead and pull down that the user input into the user input variable. Then I can check to see if it's valid based off my criteria, which is the number has to be between 5 and 10. So if I say if user input is greater than 5 and user input is smaller than 10, then I know it's between 5 and 10, and what I want to do is break. Now what break does is break will go ahead and discontinue the loop. It'll forcibly shut the loop down to where the loop no longer continues to execute. In fact, it'll do that immediately. So immediately after this break, execution will go right to line 20. Let's go ahead and add something in down here, though, to make this a little bit more interesting. I don't know why my program's so excited about him entering something, but it is. So then this if not continue, I don't need to do anything here because the loop will automatically continue. However, I will let them know that they failed simple instructions.
Are you typing something? Oh, there it goes. I wasn't getting a screen update.
Yes. So now if I enter 1, I get a nice little error message from my program. If I type in 22, I get the same error message. But if I were to type in 3, wow, I'm at 8. 8, it says you have entered 8. So this is a valid use case for a infinite loop. Now, continues, so in this case what we're doing here is we're using the break keyword, which it is a keyword. It's not like anything, it doesn't have a value or a type or anything like that, just a keyword that has to be terminated. It'll just, like I said before, it'll immediately just jump right out of the loop. So is everybody good on break?
Yeah, I hope that those of you, when we're over on my screen, I hope it's nowhere near as bad as what I'm seeing from Nelson's. The lag is just, yeah, like, is mine just that bad? No, it's not. Nelson, you need to get a better computer.
Maybe it's just my.
Maybe it's your what?
Well, I agree with you on that because now you're talking about my MacBook.
Yeah, it's just horridly laggy, and your voice
Hello?
your voice keeps cutting out.
You just.
Yep. Yeah,
off.
you're just dropping and coming and dropping and.
Yeah.
Are you using wireless right now? Okay,
Yes.
well, I am too, actually. Okay, so anyways, well, let me help Nelson out here. So the key thing about break is that break is just going to break you out of, in this case here, of this loop that you're in. But with break, it's when it's executed while in a while, a for, or a do while, and also a switch. But again, we'll talk about switches later. Then it causes immediate exit, and then the other one is continue. And with continue, where break will exit you out, what continue will do is basically skip the rest of what is in that iteration of the loop and jump back up to the top and continue.
Right. So in this case, let's say we wanted to. I mean, we could have just invert this basically to where instead of checking to see if it's valid, I can check to see if it's invalid. So I can say if user input is smaller than 5 or user input is greater than 10, then I'm going to print out the error message. And then instead of break, I'm going to continue. And then I'm going to take the rest of my program and put it inside the loop. So now what you should see here is the difference. The biggest difference here is that so we can still input invalid numbers. But if I input a valid number, it continues the program. It just continues to loop over and over again instead of before where it broke out of the loop, if that makes sense.
It should make sense to everybody. I mean, continue is just going to, continue. Yep.
Keep doing.
So this is an example of why you'd want to, an infinite loop. Another example is while one, for a game loop, and you're just going to stay inside your game loop. Maybe go through and query all of the actors, update all of the actors, run dynamic simulations, run anything dealing with sounds, etc. But then, in all of that, perhaps somebody had exited out, and then you'll end up breaking out of the while instead of having to put the a condition, an expression that will evaluate based off of did somebody hit exit inside the while itself. So just something to think about. And I'm gonna do the following because I've already got some requests that have come in over on the questions panel, and I know Nelson is almost dead. But I guess what we'll do is divide this. Let me go ahead and take this back to my screen, and let me talk about how we're going to do this. Make me a presenter.
Guess my program wasn't.
Your program was epic.
Yay!
It was so amazing I didn't even know how to respond.
I sat here and cried.
Yeah, she did. She wept tears of joy at the epicness.
Mm-hmm.
Okay, and Jen's going clap, clap, clap. So.
And it's on a loop.
So, yeah, exactly. So she can clap 60 times if she needs to. All right. What we need to do is we're going to need to divide this class up. We'll divide it up into a part 1 and a part 2 because I am killing people who want to be involved through the whole thing and don't want to die out, which means I need to figure out how we need to divide this up. And I'm thinking... Would it be horrible if I know I was going to use Thursday night for doing the drawing stuff, which I still can. I can do that a little bit later.
There's drawings.
No, I was talking of work and open office hours. What would you guys think about if I did a meeting time like Thursday night for us to do part 2? Dementis is cool with that. I know, Mandrel. Here's the thing, though. I am very much afraid that I'm starting to rush now. Well, yes, Mandrel. It will be on video. There's no way we would do anything without it being on video. I'd never let you guys miss out on anything. We could do it tomorrow. The only problem I have with tomorrow is I've got Thomas's very last class that he's got to do at 7 o'clock, I think.
6.
6 o'clock. Yes,
Yeah.
all confusing to me. So, and let me go ahead and explain. So for part 2, like I was saying earlier, we're getting into functions. And functions really lie at the very heart of any application that you write. Because you're going to take your code and you're going to modularize it down into a bunch of functions. And in getting into functions, this is it gets a bit tricky for people that are completely new to working with programming, because there's a lot of things that we can run into that becomes confusing to a beginner when we start getting into parameter lists, return types, prototypes, and I would still very much like to go into the function call stack and draw that out and give a visual demonstration of what is happening. I think that's very important. I think it's very cool to see. So it's kind of I'm pushing as hard as I can to squeeze in as much content as I can, but I know the call stack alone will probably have me talking for 15 minutes. The recursion part will probably have me talking for 15 to 30 minutes. This is all without me having you guys do anything. Function prototype. So we're looking at, another 2 to 3 hours. 2 to 4 if I don't have to worry about time at all. So I don't want anyone to feel cheated, by no means. This is just a really good stopping point for the first part, and we can still put homework up with what you guys have learned a lot tonight. Oh, Jen, just for the record, I'm golden. Yeah, I'll eat some dinner, then I'll do some digital painting, and then I'll do some reading tonight, and I'm golden. But I'm starting to feel bad. We're now losing more people, and Nelson is almost not able to explain things anymore. He sounds horrible. So that, again, I want to give you guys the best of what I can possibly provide, and I feel that this is the best way to do it. But I want to make sure you guys are cool with it, and it looks like pretty much everyone is. And we'll still have a homework assignment that will be going up, and Nelson and I are going to have to talk about it to decide which one I want to put up because we haven't gone through functions. But I'm jumping back over.
It.
But we will post it. Don't worry about it tonight. It'll be up there tomorrow. But as far as lecture goes, right now we've got right at 4 hours of just the lecture stuff, not including any of the pauses and all. So, yeah, this is pretty big tonight. I know I'm very verbose. I am passionate about those that are new to this. I'm really wanting you guys to grasp it. And maybe this is a great spot anyways, so that those of you that are hearing some of these things for the first time can digest, and then we hit a whole new set of things with functions. So, Nina, your head feeling a little fried?
It's a good stopping point. No, because then I can... all the loops and stuff are like, whoa. So it'd be definitely a good way to digest all that.
Okay, cool. And thank you very much, Jen. She also liked the explanation of concepts and all. I really appreciate that, guys. And Angela's buttocks hurt from all the hours of sitting in a chair, I guess. So anyways, for those of you that have watched this video afterwards, guys, thank you very much for making it all the way to right here. For those of you that stayed with me in class tonight, everybody that was here for most of the night was awesome. You guys are epic. I kid you not. You guys are epic. Thank you. I mean, all of the names that I'm seeing over here typing in BuzzNet and the names I'm looking at over on the attendees list on the right side monitor, it means a lot to me. You guys really, these names
Proud
really,
of you guys.
These names really stick out to me. I commit these things to memory. I mean, students and their determination and drive is something that has always meant a lot to me, and it's always served as fuel to me. So the fact that so many of you guys have stayed all the way up to right now just really, I don't know, it just really fuels me. That's why I could continue going, because I have so many of you guys still with us. Like, yeah, but okay, I'm listening to what people are saying, and we'll cut it here. We'll pick back up probably Thursday, and then heavens knows I'll probably go forever again, because I just want things to be as clear and concise as I possibly can. Plus, you guys should be fresh, and you'll be able to code out some of these challenges that I've got for you that right now some of you might have a lot of difficulty with because you're getting tired. So we'll wrap this for tonight. Keep a watch over in the Member Sponsor Lounge for me to announce a new meeting night. I just want to verify a few things with Nelson and see if we can get Thursday night in there.
And homework.
And then also homework will be up there at some point tonight. Got a time in mind? Thursday night. I don't know. Is around 6 work for you guys still, or maybe 7? And I'm going by Central Time, my time. So Well, remember the drawing classes. The class is still on
Friday.
What I was going to do is start offering a second session every week with drawing. And I don't even know if Derek was going to be available Thursday. That's just what I was thinking today. Mr. Pencil Shavings, what day I'm looking at Thursday for doing this? Second half. Okay, cool. So, Jen, yeah, we may just, I may talk with Derek and then go ahead and put them on schedule starting next week, which is good because that allows me to look carefully at our schedule because we're going to be doing all of the mobile programming classes next week as well. So, a lot of stuff that's going on here right now at 3D Buzz. And some of you guys that are just hardcore dedicated and in like every class, getting to know you guys well. It's awesome. So we'll conclude tonight. Thank you guys so very much. I'll get those registration links up. MMO Dust. They've got it. I really want to try to get them up tonight. I'll do my best. But either way, you'll get in tonight or tomorrow for sure. So thank you guys. Thank you very much. You guys have a wonderful night, and I will see you again here, I guess, Thursday night. So be good, everyone.
Woo-hoo!
Love you guys. You guys are awesome.
Bye.
Bye, everyone.
See you, everyone.